Good morning to one and all. Myself, Ms. Mansi Damle from School of Science, Sandip University. Pleased to welcome you all for a 3-day virtual conference on current trends in waste treatment, reuse, and valorization. I welcome you all for this conference. Firstly, I would like to invite Dr. Razia Kutti, Head of Department of Microbiology and Life Science, University Nashik, for introducing us to the conference theme and welcoming the delegates, dignitaries, and participants. Over to you, madam.
Good morning, everybody. It is a great pleasure to extend warm welcome to all the dignitaries, Professor Chetan Chaudhary, Registrar Sandip University, Dr. Pankaj Chaudhary, President, Society of Green Environment, Dr. Sachin Munde, Dean, School of Science, Sandip University, Dr. Vinit, Secretary, Society of Green Environment, the eminent researchers, faculties, and dear students, to the 3-day e-conference on waste, reuse, and valorization. So I would like to state here that the bioremediation research has been intensified due to its integration with omics and nanotechnology. And we have shaped this conference which would address all the themes which are of significance in the area of waste treatment, reuse, and valorization. We have addressed here the emerging pollutants, its characterization, what are the current challenges faced in physical methods of remediation, the hybrid treatment technology, which is emerging as one of the latest development in the field of current waste treatment, as well as the valorization, which is of immense significance in the current situation where we are dealing with enormous problems emerging from the waste generated from various aspects. So, we would make all our efforts to inspire our students, the researchers, the faculties who would learn a lot from this conference, and also we would aim to inspire our students, as from the speakers list we can see that we have very eminent speakers, the young and dynamic researchers. I am sure they would pave the way for all the young researchers and faculties attending this conference and who are viewing this live. Thank you.
Thank you, ma'am, for introducing us with the conference theme. Soon we will proceed further. So once again, good morning, everyone. I would like to again introduce you all that we are conducting a 3-day virtual conference on current trends in waste treatment, its reuse and valorization. I welcome you all for this conference. So this virtual 3-day e-conference is been arranged by School of Science, Sandip University, Nashik in association with Society for Green Environment, New Delhi, India. So I welcome you all again, once again for the conference, and we will proceed further within a minute.
मेरा स्क्रीन की तरफ
So I feel immense pleasure that today we have with us Dr. Chetan Chaudhary, who is Registrar of Sandip University, Nashik. I request sir to kindly address us. Over to you, sir.
Am I audible?
Yes, sir.
Yeah, good morning to one and all present in the international conference hosted by the School of Sciences, Sandip University, Nashik. Uh, I welcome all the delegates from the Society of Green Environment who has given us the opportunity to host this international conference in the joint venture. As Sandeep University is concerned, is more focused, and we call ourselves our university as a 350 acres lush green campus, and it's a green environment for the students to study. So it's a very good venture to host this international conference on this waste treatment and the reuse of valorizations, oral and poster presentations and the paper presentations to be done in the 3 days of the meeting. Uh, I strongly believe that this type of conferences will lead the students, the research scholars, the faculty, and other fraternities, uh, those to upgrade their knowledge and practice these key tools of the waste management and other aspects to be considered in future aspects of the country. So I strongly believe. I once again thank the all the delegates from the Society of Green Environment who have spared their valuable time for us to contribute to this noble cause of green environment, and the for the benefit of students and the research scholars and the faculty members and all the staff here at across the country, those who have participated in this international conference. So I also thank the team, our team, School of Science, who has taken this initiative to build a better environment to work for this. So I thank all of you and wish you a great success in this international conference. Thank you very much.
Thank you very much, sir, for your encouraging words. We are really enlightened by your presence at the event. Thank you so much, sir.
Thank you very much. Thank you, Mansi.
Proceeding further now, I would like to invite Dr. Pankaj Chaudhary, President of Society for Green Environment. I request sir to please introduce us with the Society for Green Environment. Over to you, sir. Sir, please unmute your mic.
Yeah, it's sorry for disturbance. Thank you, Miss
Yes.
Mansi, and good morning to all of you, and welcome to the respected speakers and the participants. Thank you to the organizing team to giving me this wonderful opportunity to introduce the Society for Green Movement. Um, Myself, Dr. Pankaj Chaudhary, President, Society for Green Movement. I would like to introduce this society, and this society is registered under the Act of 1860, and this society is non-profitable, non-government, multidisciplinary, membership-based national organization of the individual, institution, and corporation. This society is involved in various activities, conducting, organizing national, international conferences, symposia, conferences, workshops, seminars, team training meetings, and as well as distributing publication on the theme of the environment concern. And the mandate of our SG is like a motto. Motto is to be a save the environment, protection of natural resources and services to the society, industries, and vision of our SG is to contribute in the management of environmental health of the society. And mission is our society is to the enhancement of the public awareness on conservation and upgradation of the environment and management of all from air, water, and soil, development of the happy to healthy society. Uh, Actually, we are working with different objectives like prevent environmental degradation as a result of the human activities, control human activities that contribute towards degradation of the environment, and third one, initiate measure for the improvement of our environment, increasing public awareness about the state of our environment, advocate, advocate and promote environmental friendly and sustainable technology for a green, clean, and earth. Um, Strive for the sustainable environment, social and economic developments, prosperity and health of ourselves today and for our future generation. And finally, establish and maintain an active information exchange between government and industry professionals involved with the environment management to achieve green and cost effective solution to the environment. uh, with this word, I would like to finish the introduction of this society and wish you all the best to Sandeep University and organizing committee to uh, successful mm, successful of this conference. And I would like to over this to Miss Mansi for further process.
Yes, thank you so much, sir, for being with us and introducing us with the Society for Green Environment. Thank you so much, sir.
Okay, thank you.
Hello, hello everyone. So, in a very short while, we will be going ahead with inaugural address by our Honorable Vice Chancellor, Dr. Rajendra Sinha. And I would like to tell you a few points about the focus of our conference today. As we have been witnessing various environmental issues over the last 2 decades, we are focusing our environmental protection efforts by helping the bioremediation which the natural system has provided us. The mother nature has a inherent healing technique from which we have learned a lot. So what does bioremediation mean? We are using the microorganisms for our favorable opportunities. And in this context, we are exploring various type of microorganisms, fungus, algae, and we are using all the physiological as well as molecular biology functions to understand how this interesting phenomena is carried out by the microorganisms. As we are going through the era of omic technologies, we have various techniques available like metagenomics, we have proteomics, we have the transcriptomics, which would definitely aid in developing hybrid technologies using the engineering aspect of environment as well as the physiology of the microorganisms. So we are considering in this conference the hybrid technology also as one of our themes. Compared to physico-chemical approaches which was used conventionally, we have current approaches which are integrated with various recent molecular biology tools as well as the environmental engineering techniques. The other aspect of this conference is valorization. So let me elaborate on the valorization. Valorization is a method of value addition to the bioremediation process. So we are getting two advantages. One, we are reducing the waste, we are detoxifying the waste. The second advantage is we are integrating and translating this process of waste reduction with value addition to the end product as well as byproducts of the bioremediation approaches. So hence, we will also be focusing and elaborating on the value addition part. Current value addition approaches are enormous in the sense that besides the conventional methods of manufacturing drugs, pharmaceuticals, etc., we have various antibiotics being produced by this idea and approach. Thank you.
Thank you, ma'am, for your brief introduction about the conference theme. Thank you so much. Coming upon next, I feel honored that today with us is Vice Chancellor of Sandip University, Nashik, Dr. Rajendra Sinha. I request sir to kindly address us.
Uh, it is a matter of pride that the School of Science of Sandip University hosting this mega global scientific event. The theme of the conference revolves around and its management. Scientific like this gives an opportunity to the researchers across globe to share their ideas and paves the way for the development of strategies and discoveries for the betterment of humankind. Especially such scientific conference ignite and inspire the young mind to make their career in scientific and science and technology for the better cause of humankind. In the era of knowledge, where learning, research, and innovation is important, we Sandeep University follow four pillars of national education policy: access, equity, affordability, and accountability. Really, I'm feeling very happy on this occasion, and I like to congratulate Dr. Rajia Kuti, Dr. Sachin Munde, Dr. Pankaj, Dr. Nisar, and their team. And also, I like to congratulate all the delegates, participants, researchers, and faculties who are going to benefit it from this conference. I wish you all the best. Thank you very much. Thank you very much.
Thank you, sir, for being with us today and encouraging us. Your presence and wise words will surely help magnify our cause in best possible way. Thank you so much, sir. Moving ahead, we will begin with the conference now. So I feel glad to invite our keynote speaker, Professor Sunil Kumar, Professor and Head at CSIR NIRI, Nagpur, India, as the keynote speaker, and Dr. Ronak Dankar, Assistant Professor, GD Goneka University, Haryana, India, as the session chair. I request Dr. Ronak Dankar to kindly introduce Sir with us.
A very good morning to all, and it's my great pleasure to introduce Professor Sunil Kumar and this virtual international conference. So, sir, today, sir is here to provide his insightful talk on solid waste management and circular economy and its challenges and strategies. So, Professor Sunil Kumar is a well renowned researcher having more than 22 years of experience. He's a great leader, supervisor, and undertaking research in a broader field of environmental engineering and science with focus on solid and hazardous waste management. Sir is graduate in environmental engineering and management from Indian Institute of Technology, Kharagpur, India. He completed his PhD under the joint supervisions of Dr. Sukumar Devotta, who is former director of CSIR NIRI Nagpur, who got letters from the executive director of UNEP and the president of Switzerland, and the Nobel Peace Prize in 2007 as a part of the United Nations Intergovernmental Panel on Climate Change. And Professor Somnath Mukherjee of Jodhpur University, Kolkata, India. And Sir's primary research of expertise is on solid waste management, which is related to municipal solid waste, electronic waste, over a wide range of environmental topics like contaminated sites, EIA, and wastewater treatment. His contribution is in the fields led to a citation of more than 10,000, and his H index is 46 with I-10 index of 187. The another contributing field of Sir is in the his inception at CSIR National Environmental Engineering Research Institute, India. He has publication more than 2,000 publication. He has 5 books and 40 books chapters. He has edited 10 volumes and numerous project reports to various governmental bodies and private, local, and international academic research bodies. He is the associate editor of peer-reviewed journals of the international repute, such as International Chemistry Letter, International Journal of Environmental Science and Technology, ASCE Journal of Hazardous, Toxic, and Radioactive Waste. He also serves as editorial board member in Bioresource Technology in Elsevier. He has completed more than 200 research projects as PI with 15 PhD and 20 MPhil students. He was an expert committee member for revision of solid waste management manual in India, NGT members for implementation of solid waste rules in UP, India, which is organized at international and international workshop conference, and he has delivered many invited talks at both uh, national and international platforms. Then Sir was awarded as Outstanding Scientist in 2011-2016 at CSIR NERI for his scientific excellence in the field of research and development in solid waste management. So Professor Kumar was also awarded with the most prestigious award, that is Alexander von Humboldt Stiftung Janpod Ster 2D 53173 Bonn, Germany, as a senior researcher for developing a global network and excellence for more advanced research and technology innovations. Welcome to you, sir.
Very good morning, everybody. First of all, thanks to Dr. Ronak for your kind introduction.
Thank
And
you, sir.
at the outset, I would like to thank the organizer, particularly School of Science, Sandip University, Nashik, and Society for Green Environment, Delhi, for organizing an international conference on current trends in waste treatment, use, and valorization. This is one of the hot topic, and this is the need of the hours. As we know, India has witnessed a massive growth of waste generation, right from municipal solid waste, electronic waste, this biomedical waste, construction and demolition waste, and all other wastes. And a lot of efforts have been made by the government as well as other organization, society, NGOs, and all these things to make a comprehensive management of these solid wastes. And a lot of this policy intervention has taken place since last 20 years. Many of the prestigious programs have been organized by government of India through total sanitation program, Jawaharlal Nehru urban renewal mission, and all other initiatives like Swachh Bharat Mission 1, and then now Swachh Bharat Mission 2 has come up. We have seen in Swachh Bharat Mission 1, there was a quantum jump in collection and treatment of solid waste, but there was a lack of treatment and this reuse, recycle, as well as valorization of solid wastes. So, against this background, this conference has become one of the important conference because SBM2 has also focused on waste treatment, waste processing and treatment. So this is one of the major aspects. This conference is going to come out with the findings towards achieving this 100% waste treatment, reuse, and valorization. And nowadays, the society has played a very important role in awareness, in capacity building of this waste management systems, personals involves. So only society can save the society. So this Society for Green Environment is one of the leading society initiated by Dr. Pankaj Chaudhary. And I think through this conference and many other initiatives, many things are going to be achieved. This waste treatment and reuse and valorization, as you all know, that in spite of lot of efforts initiated by at different levels, this still India is in the dilemma of linear waste management. So it is a great efforts by researchers, academicians, as well as other this practicing organization, NGOs, and society to look for to emphasize the importance of circular economy in waste management. My colleague will show the slides, but I am on the field visits, so I may not be able to give the justice as a keynote speaker in this conference. So just I want to thank the organizer for inviting me in this conference, and all thanks and all the best for 2 days program on international conference for trends in waste treatment, reuse, and valorization. Thank you very much for your kind attention.
Thank you, sir. And uh, and it's really true that only society can save the society. Thank you. It's a
Thanks.
great message, sir. Yeah. Thank you. So I'm really thankful to the conference organizer for allowing me to chair this session and for introducing to the sir. I'm thankful the School of Science, Sandip University, Society for Green Environment, Vice Chancellor of Sandip University, Professor Rajendra Sinha, Dr. Vineet Kumar, and Dr. Razia and Dr. Nishar for allowing me to this platform to chairing this session. Thank you so much. Thank you. Thanks to all.
Thank you, Dr. Sunil Kumar and Dr. Ronak Dhankar for being with us today. And thank you, Dr. Ronak Dhankar, for chairing the session. Thank you so much. So I would like to invite Dr. Vinit Kumar on behalf of Dr. Sunil Kumar. Dr. Vinit Kumar is going to present as the expert speaker, keynote speaker. Over to you, sir.
डेस्कटॉप पे हेलो नहीं नहीं शो स्क्रीन मत करो शेयर हाँ एक्चुअली मैं शेयर कर रहा हूँ मैडम एक्चुअली सर
I request Dr. Vinit Kumar to proceed with the session.
हेलो
Yes, sir, you're audible now.
हेलो हाँ एम आई ऑडिबल मैडम
Yes, sir. Yes, sir, you're audible. Sir, you may proceed with the talk. You are audible and your PPT is also visible, sir.
आपकी जा रही है आई थिंक कुछ प्रॉब्लम है तो वो मैडम को मैं शेयर करके आता हूँ ये हो नहीं रहा है यहाँ से
Sir will be joining with us very soon due to some technical error. Sir is not here actually. On behalf of our keynote speaker, Dr. Sunil Kumar, Dr. Vinit Kumar is going to present to us. He will be with us very soon. I welcome Dr. Rohit Jambulkar and I request him to proceed with the lecture. Over to you, sir. Due to some technical error that has occurred, there is a delay. We will be proceeding further very soon. We will start with our expert talks now.
Hello. Hello. Good morning, all. Myself,
Good
Dr.
morning.
Ravikiran. Yeah. I welcome you all our international conference that is current trends in waste treatment, reuse, and valorization. Today's first session, I welcome Dr. Garima Kaushik as a speaker. Madam is working as an assistant professor in Department of Environmental Science, School of Earth Science, and Central University of Rajasthan. She is working from 2011. She is a gold medalist in BSc and MSc from University of Rajasthan. She has PhD in the field of environmental biotechnology from Jawaharlal Nehru University, New Delhi, 2009. She has also served as an environmental consultant to work with World Bank funded projects with the government of Rajasthan, namely HCWM, that is the Healthcare Waste Management, and RRLP, that is Rajasthan Rural Livelihood Project. So her area of research interest is in environmental microbiology and chiefly bioremediation of industrial effluents and biomedical waste management. She has also participated in various academic events at national and international level, and she is also the life member of many academic societies. She has the recipient of one of the prestigious awards, Devang Mehta National Education Award for the best faculty for environmental management in 2016. So she has having vast experience as an environmental biotechnologist, and we are going to listening Dr. Garima Kaushik. Madam, we are very thankful for your kind acceptance of our invitation to give the speak in our international conference. Thank you, madam. Over to you, madam.
Thank you. Thank you. Just let me know, am I audible?
Yes, ma'am, you're audible.
Okay. Thank you, Dr. Pagare. Very thankful to Sandip University and Society for Green Environment for giving me this opportunity to interact with you all. And thank you for this brief introduction also, which is not that, I mean, I do not deserve that all, but yet you have given me this opportunity. I would take it very gracefully, leading directly to the talk, which is supposed to be on bioremediation of emerging contaminants. So let me know when I'm sharing the screen if it is visible to you, please. Is this visible? Is the screen visible to you?
Yes, ma'am, it is visible. You can
Yeah.
proceed.
Yes, thank you so much. So, once again, I would like to tell you that after my PhD, I started working on bioremediation of some waste contaminants, and especially started focusing on emerging contaminants. And this talk is also on pharmaceutical compounds, which has been considered as one of the very important group of contaminants in this category of emerging area. And very recently, we have started working on, apart from pharmaceuticals, this is pharmaceutical compounds and personal care products. Then some pesticides already been in area of research from the past 2 decades, but also in the field of BPA and plastics, that is microplastics. So I would like to take the story of pharmaceuticals and personal care products. So as we all know that the daily, we all of us, in fact, if we talk about all those who are listening to this talk today, if we look into our daily routine, we have been using number of personal care products and pharmaceutical compounds, even pharmaceutical compounds like daily BP tablets, or you can say diabetes tablets, or even simple cold and flu tablets have been become a part of our daily life. So, and from morning brush to night cold creams, we have been using these different, around 80 different classes of these kinds of compounds in our daily routine. So, among these, the pharmaceuticals are exposed to the environment through various direct and indirect routes. And among the direct routes are hospitals, households, industries, and wastewater treatment plants, which are the direct sources of these compounds into the environment. And human excretion, animal excretion, and improper disposal of these categories of wastage from households. For example, when a drug is expired, we do not go for a proper treatment or disposal mechanism. In fact, we go with an indirect mechanism, and we actually make it a part of a solid waste which is generated out of a household daily. So these become the indirect sources of such waste in the environment. So there are different pathways that has created after medicinal or use of human and animals. And if we see after excretion and finding a way to the waste disposal unit and municipal wastewater, it becomes of the part of domestic waste, as I told this with this example. They ultimately find their, if this is a liquid waste, it will find its way in sewage treatment plant. And if it is a solid part of a solid waste, then it will go to the waste disposal site. And all of them all together find their way into the waters, that is surface water or groundwater. And finally, they are again coming back to the cycle through food cycle or water cycle into the drinking water. So even after medicinal products which are used for animals, treating animals, it is again finding its way through excretion, manure, soil, and surface water or groundwater. So this is how the waste which are treated by every individual becomes the part of that chemical cycling, and again coming to us in the form of a chain product. So what is the first forewarning which was given by Stum and Jollinger and Fair in 1965, and they considered them as producing a potential adverse effect of pharmaceuticals in municipal wastewater. And the presence of these pharmaceutical residues in environment was first time reported by Tabak and Bunch in 1970. And they found that these compounds, which are so much physiologically active even in very small amounts. So, you know, these hormones and these the drugs of high chemical properties, they are actually they are taken in a very small, very milligrams or very small amounts for treatment, and if they are discarded in the environment, so if even these small amounts are so much threat, giving so much threat to micro and macroorganisms in the open environment, because they are physiologically active. So it is not like that whatever medicine is discarded, it is not active, it is actually active, and hence they can have a huge impact on the all the living and non-living living biota in the ecosystem. So the story of emerging contaminants is now from micro, they have become major pollutants. However, it is a topic of very important priority, which actually escaped from getting noted because there is no established guidelines about these contaminants. So, from nano to microgram concentration of these analgesics or antibiotics or anti-inflammatories or lipid regulators or beta blockers and steroids and hormones are detected in environmental matrices. And a very recent paper is available at Chemosphere, where wastewater treatment and emerging contaminants, a bibliometric analysis is available in this volume, is this journal. So, if we talk about the distribution of these pharmaceuticals detected in surface, groundwater, and tap water and drinking water, then we find that even in India, there are almost 31 to 100 different types of pharmaceuticals are available in surface, ground, and drinking water. So you can see the distribution of these pharmaceuticals in these types of waters, and actually more or less they are widely distributed. So the scenario, if we talk about scenario of pharmaceutical pollution in India, which is actually has emerged as one of the leading supplier, and we have seen in the past 3 years also, it has been a leading supplier in case of vaccines, also supplying corona vaccine, and then it is a supplier of generic drug and produces too much of revenues out of that. This pharmaceutical industry is one of the fastest growing segment of Indian economy and has experienced a rapid and sustained expansion. Since the second half of the 20th century, the market is expected to grow by 100 billion by 2025. So, if we talk about how these compounds form a cyclic path, if you can see there are a number of pictures which shows their improper disposal and the pathways they follow after entering to a healthcare center or a household, they are again coming back from different routes in the form of food chain or water chain. So what are the impacts which were highlighted because of this pharmaceutical compounds as a contaminant in our environment? That is increased resistance among natural bacterial population. We have been listening or reading this term of antibiotic resistance in the microflora of the environment. So these actually the compounds accumulate in the fat tissues of animals and enter into the food chain. They poses potential impact on organisms, include delayed development in fish, delayed metamorphosis in frogs, and altered behavior and reproductions. This actually led to a decline in the vulture population because of the increased use of a one drug among the cattle population, that is diclofenac, which highlighted in 2004 that the number of these vultures actually declined, and the reason was that they fed on the cattle's on the dead bodies of those cattle which are actually treated by this drug diclofenac. So number of compounds have been detected and their harmful effects are also listed over here. That is diclofenac, ibuprofen, enrofloxacin and other antibiotics. Cytotoxins are severe category of drugs and ethinyl estradiol. These poses a number of harmful effects on renal impairment of fish and birds, evolution of antibiotic resistant resistant pathogenic microbes leading to ineffectiveness, then production of reproductive toxins in aquatic animals and tumors in plants, affects the fertility and development of fish, reptiles, and other aquatic invertebrates. So there is a need to actually eliminate these compounds from our ecosystem. And among the physicochemical and biological methods of treatment, I find that the biological methods are more eco-friendly methods and they are robust in the form of that they actually end up in producing inert end products. So I actually vote for these bioremediation kind of strategies for treating these kind of contaminants. So pharmaceuticals have been in environment demonstrate incomplete degradation. That means they are either slowly degrading or very less degrading. So we have to eliminate them by treatment plants and remove them from the aquatic environment. And the microorganisms have been identified as important degraders of organic matter and different organic contaminants, including pharmaceuticals. Bacteria, fungi are the two most important group of organisms that are best able to degrade organic compounds. So one of my scholar actually had this as a topic of a PhD, and we actually collected these wastewater samples from one of the pharmaceutical manufacturing unit in Jaipur, and we analyzed the physicochemical parameters of this wastewater collected from the pharmaceutical industry, in which COD actually, which indicates about organic and inorganic strength of the water, was very high in that case. And the other drugs which were identified in that wastewater was ibuprofen, levofloxacin, ciprofloxacin, metronidazole, and paracetamol. So the molecular weight was also identified, and these drugs which were identified with the help of actually Cutoff mass spectrum, so that the actual mass number and the number of the peaks which are showing in that wastewater was actually demonstrating the presence of these compounds in that industrial wastewater. So we started with the microbial isolation of the microbial strains that are capable of degrading this kind of wastewater. And we believe that the native population, that is the microbes which are already adapted to this contaminated environment, actually helps a lot in degrading these compounds, because they are first of all they are already adapted to that contaminant, and the secondly, slowly and steadily they are even faster in degrading as compared to the other natural microbes which are not adapted to that contamination. So we started with serially diluting those serial, with the help of serial dilution we could be able to isolate at least 6 types of bacterial strains, and among them only one strain we choose for our further studies, because it was showing much higher capacity to degrade total COD of the water which was collected. And finally we could be able to identify that microbial species Micrococcus unanensis based on 16s RDNA sequencing. So the chemical oxygen demand actually represent the measure of the total water inorganic and organic contents, and it is commonly used in the wastewater samples as an indicator of pollution. So it was measured, and initial experiments were done with the help of this method, that to demonstrate whether the microbe is efficient enough to decrease the COD of the treated water or not. So the COD removal efficiency of the wastewater at different time interval was studied, and at 24 hours we could be able to see that even this bacteria could reduce much amount of COD within 24 hours of the experiment. So preliminary experiments were conducted to improve the efficiency of the whole process, and our lab also specializes in bio engineering of the processes, that is optimization of process parameters and growth factors, which actually play a very important role in developing or in optimizing the efficiency of the total bioprocess. So for this, we generally provide the microbe with the additional carbon and nitrogen sources, which are acting as a growth factors. And apart from that, pH, inoculum size, temperature, duration of the experiment, and aeration also equally plays a very important role in total efficiency of the bioprocess. And hence, these parameters were screened and optimized, and after optimization of favorable conditions, these parameters were used in a process optimization for biodegradation of one standard drug which we used in our experiment as ibuprofen, and then this standardized technique was applied to the total pharmaceutical industry wastewater. So after selecting the suitable carbon and nitrogen sources, which we identified that dextrose, and in fact in this case nitrogen source was peptone, which was showing much higher efficiency as a favorable carbon and nitrogen products. And then we again went for this bioprocess optimization through design of experiment technique. So there are number of techniques, tools are available. Few of them are factorial design, response surface design, and Taguchi method. And for this particular study, we relied on Taguchi's method, which is based on orthogonal array experiments. Orthogonal arrays are a well set of balanced experiment that serve as objective functions for optimization. So this array or this Taguchi method actually works on 4 phases. First phase is to determine the factors and the conditions on which which are basically your first stage of experiments. For example, if you want to find out which carbon source is more favorable or which nitrogen source is more favorable, or among the different pH, for example, 6, 7, 8, 9, or 7, 8, 9, 10. If we actually screen some of them, for example, 6 or 7 is the favorable one where the micro performs its best, then we have to do these first set of experiments in order to find out what are the factors and what are the levels which can play a significant role in the total experimentation. So factors are growth factors and process parameters, and levels are here in this Taguchi method. There are two levels. In fact, in some experiments there are four levels also, but two in the sense of lower and higher. For example, if I talk about dextrose, at a lower level, I keep 1 mg per liter as my optimum condition, or 2 mg per liter. So one will be my lower level and two will be my higher level. The second phase of experiment will be design of a matrix. Design means that is actually given by the software Qualitech, and it gives a number of orthogonal arrays where you can plan your experiment as per the design which is developed by the software. Then you conduct the experiment. That is your phase two. So you conduct your experiments as per the design which is produced by the software, and the phase three is analyze the data. So you conduct experiments till the time period which is given by the software, then you extract the data out of it. Whatever experiment you have to do after that experimentation, you will have those results, and then you will start realizing or analyzing them. And then the phase four is your validation of experiments. So you will analyze the data based on all these things. That is, which factor was most contributing factor, what was the relative factor interaction, how much is, what are the determination of optimum levels for the experimentation. There is also a method, ANOVA technique, and you can analyze this variance and performance under optional conditions. And after that, when you have all the results, you will ultimately perform a validation experiment just to check whether all these conditions which are predicted by the software, and I have also performed my experiment just to recheck it, whether I will be able to obtain the same result in this validation experiment or not. So fortunately, you get all these. So this is the design which is given by the Kabuchi software, where one is the lower level and two is the higher level. For example, in case of carbon, which the carbon source favored by the microbe, that is dextrose, 1.1% weight by volume was the this one level one, and 0.15% weight by volume was designated as level 2. Similarly, in case of nitrogen, and these are the levels. In case of pH, it was 7 and 8 pH. Then inoculum size was also different, 2 and 4 as lower and higher levels. Then RPM and duration of the experiment, that is 6 hours or 12 hours. Then temperature was also a significant factor in the total bioprocess, and here 25 degrees and 35 degrees were selected. So this was you can see serial number 1 to 8. So total 8 experiments were conducted based on these levels which are given by the software, right? So after that, out of the 8 runs, percentage COD reduction was detected. And we can see in experiment number 6, it was showing the highest COD reduction, which was also validated by analysis of variance. And this gives that how what is the degree of freedom and how each and every factor is contributing. So you can see percentage contribution of each factor in the last column, and here carbon source was the highest contributing factor in the total bioprocess. So here, this is a cumulative. All these data are also obtained by the software after you feed the total analyzed result after the experiments. So you can see there that this is a level description. This was the experiment number 6, and these are the levels which were used for the following parameters. And the highest contributing factor was carbon, that is 9 out of the total columns. 9, that is highest number, was given to carbon source, and the least contributing factor was temperature. So expected result at optimum condition is 70% reduction. And actually that is a validation phase 4 of this Taguchi design. It showed that actual CO2 reduction of the wastewater was achieved to 82%, which is very near to the software. This is the beauty of using these kind of softwares or optimization softwares in your bioprocesses, that they actually reduce the time and number of trials of your experimentation, and you actually receive the highest output what you want to achieve out of your analysis. So this was validated by using different instrumentation in the study. And the first one was UV spectrophotometer, in which the degradation of ibuprofen in the wastewater after optimization was studied, and we can find there is a change in the peak shift of the treated and untreated wastewater. Further, also analyzed by HPLC, and final degradation of ibuprofen, a particular compound was detected in the wastewater, which we also used as a standard drug in that. And we could be able to see that there was an 81.84% reduction in the total concentration of ibuprofen. So before and after, the concentration reduced to this much. So analysis of degradation by HPLC of ibuprofen and the wastewater. So it was before degradation, there was a peak change and area under curve change was also demonstrated. Then in total wastewater, the area under curve was this, and area under curve was this after degradation of the total wastewater. Some of the mass spec was done. So in this case, ibuprofen degradation was done, and its pathway was generated using this Q-top mass spectra. And we can see over here, this is the complete drug, that is ibuprofen, and it was having a mass by Z ratio to 2.12, and it actually, this was the path which was developed after looking into what daughter products were produced in Q-top mass spectra. So we actually formulated this pathway of degradation with the help of number of compounds that were detected in the as the daughter products in the spectra. So it could lead to this kind of a pathway or this kind of a pathway where the end product is very simple as compared to the parent compound. So it could have gone to dehydration, demethylation, decarboxylation, or it could have followed this way, that is hydroxylation, ring opening of the chain compound, and then open chain compound. So this is the transformation pathway of ibuprofen, which was generated after Q-top mass spectra of the degraded sample. So proposed transformation pathway of various other drugs which were identified in the wastewater. For example, this is for ofloxacin and this is for paracetamol. It also demonstrated ring opening of the compound and dehydrogenation. Similarly, here decarboxylation took place. And thus it says that occurrence of pharmaceutical compounds in the environment can be very dangerous, because these compounds, one person is taking milligram amount, and you can imagine every household is discarding, every healthcare center is discarding. If there is no proper method for treatment of such kind of physiologically active drugs, then it will be a very dangerous plant or site for the environment, and it will be very difficult for us to control that. So the concerns have been raised to mitigate this problem, and this pharmaceuticals, even there is no policy mandate for these kind of compounds or imagine contaminants with the regulatory agencies like PWD, Public Water Works Departments. So even the water which is being supplied to the households, it is not having any kind of policy that we must check these emerging contaminants. Now they are actually showing their presence from the past decade, and still there is no policy mandate. So we identified that the bacterial stain was very efficient degrader for particular drug as a specific and for the complete wastewater also. And one of the software or the methodology which was used to improve the process of the total bioprocess in achieving best possible combination of factors. So this is study actually demonstrates the new dimensions for enhancing the treatment of particularly pharmaceutical industry wastewater by bacteria. So this is my group, and this is the candidate who actually worked on pharmaceutical industry wastewater. The other people also works on tannery wastewater, some of the polyaromatic hydrocarbons, and one is working on organophosphates, pesticides. So would like to take you a glance of Sivraj campus. We have 48 programs, 12 schools, 30 departments, and thank you for your kind attention. So I would be happy if there are any questions.
Thank you, Dr. Garima Madam. Really, you have chosen very wonderful topic, that is bioremediation of emerging contaminants and pharmaceutical compounds. Really, always we think about this bioremediation and all, but regarding to pharmaceutical companies, what effluents are coming, and really we need to think on that. But madam, before going to other questions, I have one small question. Whether really regulatory bodies has any check on such this thing effluent which is coming from the pharmaceutical industry?
See, as far as industry is concerned, there is a common treatment facility for all the industries which they have to follow to treat this waste or wastewater which is generated by the industry. We all know that. But as far as how much the indirect methods through which these compounds or these contaminants are leading to the ecosystem, there is no check for that. So that is why
Okay.
it is the problem of emerging nature. It's not
Yeah.
in the process of mandate. Still, there is no regulatory agency to check these emerging. If you go to any public water department, there is they check all those conventional chemical parameters, COD, POD, some heavy metals and all that. But they will not check these because they do not have any mandate on that.
Because we always listen that this company has been closed, that company has been closed, but we never heard this pharmaceutical company has been closed because of such issues.
Yes, and you must have seen in the slides also that India is actually leading in this sector. So we are at the worst, going to be the worst condition in case of pharmaceutical waste in our environment.
Yeah, we should.
Hyderabad already
Yes,
seen such effects, even in Himachal also. These are leading manufacturers in Indian continent.
yeah, we need to take care of all these things. Uh, I call Mansi Madam. Madam, if you have any questions from our audience.
I have a question, madam.
Yeah.
Regarding the wastewater you have talked about.
So, was this synthetic wastewater, or it was like the wastewater you got from these pharmaceutical companies?
Yeah, it was wastewater from the pharmaceutical industry. First, we identified which compounds were present in that industrial wastewater, and then as
Okay.
a standard compound, we used ibuprofen.
Okay. So, when you are dealing with the wastewater coming from the pharmaceutical industries, uh, do you have any like solubility information about the various components or the saturation of any of the compounds and how those saturation contribute to the effect on physiology of the bacteria which you have selected?
No, no, actually, no, not in terms of this, but we randomly collected samples. We took it in the lab and started analyzing compounds as well as the microbial population, which is already there as native population of that contaminated.
Okay. Okay. Thank you.
Thank you, Madam. Mansi Madam, is there any question from audience?
No more questions right now we have, sir. Thank you, Garima madam, and
Thank you
thank
so
you,
much.
Dr.
Thank you,
Pagari.
Dr. Vinny. Thank you, Dr. Pagari, and all the team. I wish good luck to the complete 3 days international conference program. Thank you so much.
Thank you, madam.
Thank you, Madam.
Coming up on next, I would like to invite Dr. Justine Samuel. I request Dr. Pagare to chair the session. Over to you, sir.
Thank you, Madam. Welcome, Dr. Justin Samuel. We welcome you in our international conference, Current Trends in Waste Treatment, Reuse and Valorization. Yeah. I'm very happy to introduce Dr. Justin. Dr. Justin, he is working as an assistant professor in School of Bioengineering and Biosciences. He is head of department West of the West Valorization Research Laboratory at Lovely Professional University. Sir is heading the department of West Valorization Research Lab, and he has done his PhD from Environmental Biotechnology, VIT University. He is having decade of experience in pathways and impact assessment, waste treatment, bioremediation, water security, constructed wetland, which is very important topic, reuse studies, and all important areas of phytoremediation and all he is working. He is also having work experience with our agencies like Department of Science and Technology, Department of Biotechnology, CSIR, and various others. He is having experience in developing sustainable solutions for industrial effluent treatment. He has been part of India and Europe meetings for developing special strategies for such issues. He is having international level as a consultant for Kuwait, and at national level he is working as a consultant for various research organizations. He is also the part of editorial board of various agencies at national and international level. Sir has successfully completed various research projects also, and right now he is working on the international project as a consultant for Kuwait. So, sir, I welcome you for our conference, and really you are talking on very important topic, that is phytoremediation, a green approach, and sustainable solution. We are very much eager to listen you, sir, and thank you for accepting our invitation for your speech, sir. Thank you, sir. Over to you, sir.
Thank you, Dr. Ravikaran. I hope I'm audible. Am I?
Yes, sir. You are audible.
Thank you. Thank you. Thank you for that wonderful introduction. And thanks to Sandip University as well as the Society for Green Environment, which is, invited me for this invited talk. So, as we were hearing our eminent speakers who were talking, I really like the work that was presented by Dr. Garima and Dr. Sunil. He had present. He is, very popular in this field. We know him very well. So I thank you all for organizing this wonderful event so that students and faculties and everyone from every stakeholders can benefit from this, at the same time share the inputs. So okay, so to my talk, I hope it's visible. One second. Is the screen visible?
Yes, sir, it is visible. You can proceed.
Okay, thank you. Thank you. So today I'm going to talk about phycoremediation, green approach and sustainable solution. So we all know that the waste in the environment is increasing tremendously. And we know that a lot of industrial waste and a lot of other waste, because they are ending up in the environment. And if you see industrial waste, because domestic waste and other waste, we have a lot of treatment technology and people are working on. But when we take industrial waste, when we talk about industrial waste treatment and reuse, that's a very big challenge actually. And the reason is industrial waste consists of pollutants at a huge quantity, which is concentrated in one place. So industrial effluent contains a lot of concentration of organic and inorganic nutrients, and it is also one of the main causes of lot of ecological degradation or damage, which are very difficult to reverse. So what we are trying to do nowadays is we are trying to minimize the impact it has on the environment. That's what we are doing. But when we talk about reversing those degraded environments, then that's a big challenge actually. So we are doing two things. One, people are working on minimizing the pollution. The other thing is people are trying to make sure that the environment is rejuvenated or reversed. Now, if such released untreated wastewater enters our river, lake, stream, land, everywhere, you will see that it has different impacts. Okay, and mostly, if you see when it enters water, there is a lot of oxygen depletion that happens in the water, and that's a very direct effect due to the microbial oxidation of organic pollutants. Because we mostly think that microorganisms are very beneficial. Yes, they are. So, in this world, if you see microorganisms carry out their work very properly and they do their metabolism as usual. Now, you force microorganism into an environment, okay, where they have to survive. It's a competition because we all know that survival of the fittest. The microorganisms are the best adaptation. If you call the adaptation and surviving, it is the microorganisms. So what they do microbial oxidation, and we may consider it as a treatment. But what happens in turn is the oxygen is depleted, and more often you can see that the other organic pollutants are completely oxidized, and the dissolved oxygen level of the water comes down. Now many people working on pollutants like heavy metals, people will be working on organic pollutants and a lot of things, but if you see, everything settles to one point where the water should be water which is every organism can be surviving there. Yes, that's the main focus. So when we want the water to be such a water, then dissolved oxygen is very, very important. If you have a fish tank at your home, even though you have fishes there and you have all the food for the fish, you have clean water, but still what you will be doing, you will be aerating the water, isn't it? So why do we aerate the water? We know that the dissolved oxygen of the water has to be maintained because there are microorganisms which is taking up those oxygen. There is fish which is taking up the oxygen. So you have to make sure that the dissolved oxygen is maintained in such a way. So if we consider the earth is consisting of more of water than land. And inside this water, we are pumping in the waste materials, whatever we have. Ultimately, what happens? Out of sight, it doesn't mean that it is not there. It is out of sight, that's it. But it is still there. It is depleting the oxygen. Depleting oxygen, what happens? The marine organisms, the ecosystem is completely damaged. So you know that you would have heard about the terms called eutrophication, which is very common in school days. Also, you would have studied about eutrophication, and everybody knows. So oxygen in the water is completely depleted, and how to restore it? How do we restore it? In nature, if you see the natural water flow in the nature, if you see mountains and other places, the water crosses, and when it reaches, it gets oxidized. How? You see the waters flowing through the rocks, and everywhere it falls, you can see the splash of water into multiple tiny, tiny particles, right? And whenever it goes, you can see the air is actually getting mixed. The oxygen is getting mixed with the water, and it is getting aerated. And many places, such aeration systems are used. In industries also, such systems are used. But is it very sufficient? No, it is not sufficient. But in nature, there is already a process which is happening, which the scientists have understood. But to apply it in large scale, it has been difficult. And today we are going to discuss about those things. First, let's see the problem. Now, if you see the world map over here, I hope all of you can see this slide. So if you see the whole world map over here, you can see the hypoxic areas and the areas where the oxygen level is sufficient. So in the water, if you see, you can see this places in water. And in India, if you see, these are the hypoxic zones identified in a global map. And you can see there are, just see both the sides of India, you can see that the oxygen level is lesser. Okay. And this is a global map which shows the low and declining oxygen levels in the open ocean and the coastal waters. And for inland water system, we don't have a map like this. And I hope people will work and make a map for this. So the map indicates actually where a lot of anthropological activities takes place, and the oxygen declines to lesser than 2 mg per liter. Now, is it serious? Yes, it is serious. Now, because we should know that, I think all of you will agree that, diatoms, right? Everybody knows diatoms. Diatoms are the organisms which supply oxygen to us. And if you see, 1/4 of the oxygen that we need is supplied by diatoms. So we don't depend on trees alone for the oxygen. Okay, we are depending on diatoms also. Now, diatoms need water to survive. So there are so many diatoms that are surviving in this aquatic environment. Just imagine the oxygen level depleting over here, putting a stress on the diatoms, and we lose the ecosystem over there. We call it as the ecological balance. If we lose there, then we are the ones who are going to suffer in shortage of oxygen. So yes, everybody has have spoken in different angles. So I am going to talk about this particular important aspect as oxygen, very important thing. So the oxygen in the ocean or in any of the inland water source is very, very important. Now there are a lot of red dots you can see, and I hope they convert into blue. And yes, due to strict actions, we can convert them into blue ones, and it will be better. You can see the fishes. There are so many fishes that die. Not only fish, the entire aqua ecosystem suffers due to oxygen stress. So now we know that this is the problem we know. Now to solve this problem, there are a lot of treatment methods available. Okay, yes, in the entire world, there are every nook and corner you can find people working on a solution for this. Okay, you will see a student who is studying in 5th standard, 6th standard also talking about this and working. So that is very good thing that entire world is actually focusing on this. So we have a lot of conventional methods which have been developed since a long time, like primary treatment, secondary treatment, tertiary treatment. So what is a primary treatment? We know that removal of large and suspended particles, okay, following methods like precipitation, flocculation, or filtration, any of these, we call them as primary treatment method. And then secondary treatment method, it involves all chemical methods such as pH stabilization, oxidation, they all are called as secondary treatment method. And in tertiary, we remove organic and inorganic pollutants, and it involves biological methods too in the tertiary method. Tertiary methods are sometimes a little cost intensive also in the terms of operation and management. Okay, so what are the major drawbacks in this conventional methods? What are the major drawbacks? Physical methods such as reverse osmosis and other chemical methods, they prove very costly. Okay, they're very, very costly, and not only costly in the terms of money, they're costly in terms of the secondary pollutants they generate. Okay, then addition of chemicals may increase the salinity, conductivity of the water. Then again, you have to work on decreasing the salinity of the water. It's a huge thing, because if you have to decrease the salinity of the water, you use such treatment methods where the rejection of water is more. The water treated is one thing, the rejection of water is more, which is again concentrated with salt. I have visited such sites where such rejected salt is, dispersed into the environment, and the land inside which it is dispersed into, that land is non-cultivable. And there are industries, they ask us to please help to convert those lands into cultivable lands. And we have done certain projects, but it's a long term. We need 10-15 years of continuous work to convert that land into a cultivable one. That's again a secondary issue, again generated by such treatment methods. Then there are sludge formations, which is unavoidable. I don't know whether you would have ever visited industries to see the sludge. I have worked in industries, consulting them. Literally, it takes 15 days of several tractors, okay, in one industry to remove the sludge I have witnessed. Okay, in a year, they have time where they go and collect the water from there, the sludge from there, and they remove the sludge. So it takes a long time. Now, what are they going to do with the sludge? That's a big question. Okay, now the sludge, some sludge are there which can be, converted into manure, but not every sludge. So disposing this sludge is again a very big challenge. Okay, so now when these problems are existing at one side, we all know that bioremediation could be a very good solution to overcome these problems, these secondary and tertiary issues which we face. So bioremediation, if you see, is one of the recent technologies, which is recent technology since it has been there, but recently it has been in the last 30-40 years, if you see, more advantage and more visibility bioremediation has got. So it is described as the use of microorganisms to destroy or immobilize waste materials. So I would always go with the part where we can destroy the waste materials if it is possible. We can degrade them, or we can, if it is a toxic, if we can detoxify them. That's the best thing that we can do. Now, what are the advantages? Yeah, they can be done in situ, and they are less expensive. Yes, the operation and management, if planned properly, it could be cost what minimum cost and minimal site disruption. So we don't have any issue with the sites, because this is a main concern which most of the industries also show, that the site disruption happens when we are implementing a solution in their sites. Then permanent elimination of waste is there because of bioremediation. And then long-term liability, you can trust for a long-term run. It's not that okay, it will run for 3-4 years and then you have to change everything. No. So then greater public acceptance is there because it's eco-friendly approach, and then it can be coupled with other physical and chemical methods. That's very important. Many of the times the bioremediation aspect, people try to put bioremediation as the most prime aspect. When you try to implement bioremediation as the prime aspect of remediation, then I don't think that will be accepted by any industry or anywhere. So you know that already there are a lot of technology existing. You have to try to couple the bioremediation with the existing technology. So more researchers in this direction are happening nowadays, and this is one of the advantages of bioremediation. In bioremediation, there are so many aspects. Bacterial based remediation is there, algae based remediation there is fungi based remediation is there are a lot. Bacteriophage based is there. We are going to talk about phycoremediation, and I can call it as an emerging technology, even though it has been existing since the ages. So the phycoremediation is a type of bioremediation, and it is defined in a broader sense as the use of macroalgae or microalgae for the removal or biotransforming of pollutants, including nutrients and xenobiotics from wastewater and carbon dioxide from air. Xenobiotics is one of the very common issue of emerging pollutants. Okay, and all over the world, it's a very hot topic. And yes, microalgae could be a very efficient solution for this problem. Now, why phycoremediation? See, the ability of microalgae to tackle, more than one problem at a time, okay, is the most important thing that we have to look for. We want some organism. We always look for. See, the world is always looking for single solution to multiple problems. Every time we always look for, because it's economical. At the same time, it's the feasibility increases. So here, if you see, it simultaneously solves more than one problem. And the solution, this kind of solution is not possible with conventional methods. Okay, the chemical processes, they can solve one problem at a time. Whereas microorganisms, they have the ability to handle multiple problems. And microalgae is far better in that. So second thing, that phycoremediation is important because it's case specific. As the process, it can be operated batch-wise, semi-continuous or in continuous manner, open ponds, closed environments, anywhere you can use phycoremediation. Then commercial benefits, yeah, it has a commercial angle because see, waste management can always sustain if you have waste valorization aspect to it. So there's a lot of cases are there. I hope everyone will agree with me that we have the world has got a lot of technologies of waste treatment, but everywhere it is not implementable. There are a lot of reasons. One of the reason is maintenance of that. How will you maintain that? Where will you get money from? Who is ready to pump in money into the drainage? Nobody is ready to pay money. Nobody is ready to pay money for the waste they are generating. So there were a lot of rules and regulations coming. Sometimes it was forced, sometimes it was out of big heart. But the truth is, everybody needs some revenue from that so that it can be maintained. So nowadays, if you see the valorization angle, circular economy aspects, you would have heard a lot of terms like this, which is coming under the Sustainable Development Goals, which everybody is aware. Earlier, it was the Millennium Development Goals. Now, commercial angle is very important, and algae, the phycoremediation, helps to overcome that challenge also. Then compatible. It is compatible with existing operations. Whatever existing operations we have, it is compatible with that. And then it is cost effective, as it saves power and a lot of chemicals is saved. It is cost effective. And CO2, that is the carbon dioxide sequestration, which is a solution for the threat of global warming, can be done with the help of algae, which is phycoremediation. So phycoremediation doesn't solve the problem of water, okay, the pollutants in the water. It also solves the problem that is existing in the air also. So I would always say that phycoremediation is a wonder if handled properly, if understood properly, and implemented properly. And it is flexible to handle fluctuations. Algae has the ability to handle fluctuations in quality as well as in quantity of effluent. Sometimes, when we work with varying volume, I think you when you do research, you would be studying about effect of volume, effect of initial concentration of pollutants, effect of the microbial load. There are a lot of effects which affect the remediation. But if you see, the flexible and of the flexibility of the algae is in such a way that such changes are not going to affect drastically. You won't see any much significant change in their efficiency. Then the oxygenation of the environment, which is very important. Now, there are treatment methods which will treat, but they will not oxygenate the environment. You understand? They will do one task, but phycoremediation has the potential to oxygenation of environment. Then there is possible co-production of biofuels and biofertilizers. That is one of, again, another wonder actually. It solves one problem and gives us a lot of benefits along with it. So robust to minimize automation, and its maintenance and the need for skilled operators is very less. You don't need much skilled operators. The maintenance is very easy, and it is selective to remove only the contaminants under consideration. It doesn't go and work on other unnecessary things. They're very selective also. Okay, because I have personally worked on them, and I have noted and observed such wonders actually, which I'll be sharing with you now. The sustainable, eco-friendly from an ecological perspective is also very important. Now, as we all know, all the universities and organizations and research everywhere, everybody is working towards the sustainable development goals, which is given by the United Nations, which is everyone is aware of. Now, if you see, phycoremediation is the best fit. Obviously, there are other bioremediation solutions, but phycoremediation is the best fit, okay, inside this for a long-term solution and very sustainable solution, along with a lot of value propositions to it. Now, when I talk about applications of this algae, which is helping us in treatment, if you see, bioremediation is one thing, but you can see food and nutraceuticals, where the biomass which is grown can be used, and then it can be used in animal feed. Yeah, you can see. And then pharmaceutical and cosmetics, they can be used for biofuel and bioplastic. And there are several reports on this. The only thing that has not happened till now is integration of all these things in a very proper way. There are research everywhere happening. The integration of all these has to happen, and I hope it will be happening very soon. Now, when you see the domestic wastewater, industrial wastewater, and agricultural wastewater, they contain inorganic, organic matters in them. And when you treat microalgae, okay, using microalgae, when you treat the wastewater, what do you need? You need space, you need sunlight, you need carbon dioxide. Both are available in the environment. And if you could minimize the carbon dioxide by growing algae, that's great, right? And the carbon dioxide, if it comes down, that is better. The air quality will be better. So microalgae grows there, and you can harvest the biomass. This biomass has potential of serving as a biofuel, carbohydrate source, animal feed, polymers, nutrition. We have so many multiple angles of valorization of algae. And the treated water can be used for a lot of different things. We have used the treated water from the microalgae remediation. We have used for domestic purpose, and still now there are people who are using the same solution, and those water are being used for the domestic purpose. Now, when we look at the other thing, if you see the industrial urban wastewater, okay, and the flue gases released by the industries, when those industrial wastewater comes out, you can have two process you can see. One is upstreaming and the other one is downstreaming. I'm going to be a little brief here. So in the upstreaming process, you can see you will have to do the strain selection. Yes, you have to see which algal strain is better. Okay, and you have to work with focus on the CO2 sequestration. And then cultivation techniques have to be optimized at the batch level, and then can be taken to the field level. And in the cultivation strategy, you can see the mode of cultivation. You have to understand metabolic pathways, and then factors responsible for algal cultivation in water. You have to obviously study. These are research aspects. Once it's successful in the lab scale, then yes, you have to go to the field scale also. And then in the downstream aspect, if you see, when you work with algae, you have to work on harvesting. Okay, harvesting by physical method, or chemical method, or electromagnetic method, biological method, which is the most appropriate method for your context. And then you have to also work on disruption method, where you have to mechanically disrupt or non-mechanical disruption to extract out the important materials you want as a valorization aspect. So what ultimately you get is you get a bioremediated treated water. And industrial applications, if you see, you can get biodiesel, biogas, supplements, feedstock, I already told you, then pigments,
Hello, sir.
bioplastic
Hello.
chemicals.
Hello, Dr. Justin. Hello.
Yes, sir. Yes, sir.
Yeah. Sorry to interrupt you, sir. Your PPTs are not visible, sir. So we were only on first slide only.
Was it? Oh my
Yeah.
God.
Your speaking was so fluently, and we were just listening. It
Okay.
was very wonderful. But please just see that your slides will be visible. It will be more clear, sir.
Okay. Wait a second. I thought it was visible. I'm sorry. Is it visible now?
Yeah, it is appearing now. Yeah, it is visible. Yeah.
Okay. Great.
Yeah.
So I have moved on to here. Okay. So the next thing that we are going to see is the algal culture. You can use the anaerobic digestive effluent from the agriculture waste. You can use industrial waste from where you know that carbon dioxide is produced. So most of the time, we don't think about integrating different problems into one solution. But yes, algae can do that wonder. So one, you can take the effluent. The other thing, you can take the gas. Both can be solved with algal culture. So algal biomass, when it is growing, it is just doing its own job. See, they microorganisms, they do their own job. They do their own metabolism. We have to do nothing. We have to make sure that we provide them in the right condition. So they will grow, they will multiply. And what you have to do, you just harvest the biomass and see that where appropriately it will fit in. What kind of bio-based products you can make. And oil extraction is a very well-known thing from algae. There are a lot of self-help groups, SHGs, which are working on oil extraction from the algal biomass. In India, there are a lot of women self-help groups which are working on this. And the TAGs, and once you isolate, and you can get biodiesel, you can get the N-alkanes, and you see jet fuel, gasoline, etc. So this could give you an alternative angle, or not. You cannot say entirely alternative. You can say that it can supplement some of the existing stress or pressure on the natural materials, natural resources. So that stress can be alleviated to a certain level if we start using this treatment method, and as well as if we look at the valorization aspects. Now, one case study I'm going to show you. So this work, me and my team, we had done in the KCP industry in Andhra Pradesh. So you can see here, this is a constructed wetland based technology. And this constructed wetland, when we had initially developed, we followed all the protocols and we had developed the constructed wetland. And what happened was, it's an industrial wastewater, which is sugar industry based effluent. So sugar industry effluent is very rich in sulfur and hard materials. So there was too much of salt content which couldn't be removed, and we were facing a lot of problem. So in this wetland, we had different flow, vertical as well as horizontal flow, and it's we had different substrates also. So you can see the small pipes over here. So these pipes were where we were studying the substrate based evapotranspiration. So for that calculation, we need the substrate based evaporation, and we had evaporimeter over here, and we had all this set up to study how much of water is present. Because at the end of the day, if I have to say, yes, I have treated the water, then I have to say how much volume was there. It is always the pollutant is based on pollutant volume ratio. So we tell it in mg per liter, right? So we had set up everything, but the problem that we were facing was the removal was not so much as we were expecting. Okay, and there were people who are suggesting that the removal will happen with 1 year, 2 year, let the wetland take time. So then I was wondering, when I was going through a lot of literatures, people were telling that please don't go for algae. Algae should be completely removed. Now that was the biggest challenge because algae causes clogging in wetland. So when we were wondering, I thought of using bacteria, but then bacteria surviving in the water, there were other problems that we were facing when we had a model wetland. So then we went for algae. So what I did was we developed a strategy where we will be using filamentous algae, okay, and microalgae together. So why filamentous algae? Because filamentous algae will float and they will form a network, and removal of them will be quite easy. Okay, so we had given labor work that he has to remove morning and evening every day. So for that, now I have to see that which algae is very suitable. So we had experimented the indigenous algae. We carried out a lot of experiment and found that, you know, at particular concentration, because when we are studying normally what we do in research, normally we will try to find out that at one concentration we'll keep and different concentrations, and then we will grow one organism and trying to find out which organism is able to remove. But you should know that when the initial concentration varies, every organism behaves in a different way. So here what we did, the different concentrations, as the concentration is expected to decrease as level by level in each tanks. So started using different algae over there. And when we were very successful in seeing that at one particular concentration, there was one set of algae, and another particular concentration, the other set of algae. So in all the 5 compartments, we made sure that it was growing with algae. And we made sure that the clogging doesn't happen because we had the tracers to evaluate whether the clogging is happening or not. And we had other strategies also to make sure that the clogging doesn't happen, even distribution of water was happening. So finally, we were able to achieve, we ran it for more than 1 year, and we found that the water which initially entered the wetland, okay, was when you have the decoction, if you have seen decoction, it was of that color, okay, Coca-Cola, diluted Coca-Cola, that color. And at the end, when the water reaches this particular tank, the tank you can see immediately after the wetland, okay, that's a shallow tank for UV treatment. And in that tank, the water was clean. And then we took it to the next tank, which you can see at the end. I don't know if you can see this. If you can see my cursor, this is the last tank. In this tank, we had fish grown. So we are fertigating the water here. So we cultivated the fish here. So whatever remaining organic pollutants remaining with it, it was all taken up by the fish. This water from here, when we gave it to the sugarcane irrigation, you can see 2 tanks kept here. So this was supported by the Jain Irrigations. You must be knowing them. So we worked in collaboration with Jain Irrigations. So they provided us all the irrigation materials. So it was a project for them also. So we grew a lot of plants, and I'm not showing all the results here. So the sugarcane, and we found the growth to be very comfortable. And for 3 to 4 years, we tested the soil for any change in microbial dynamics, and we didn't find any change in microbial dynamics. So the water which we treated and we gave for the plants were shown very promising. Okay, so this research gave that hope that yes, algae can be used. The only thing is we needed a labor who could remove the algae regularly. If you want to leave the algae there, then obviously it is going to travel through the substrates and going to clog. So this one solution led me to work on other aspects. So when I moved from, I had my own laboratory. So then I started to work on other aspects where we can use algae. So application in treating air pollution was the second approach which we did. So these are my students. With them, we developed a solution where the air pollution can be solved using algae, because in nature it really happens. Okay, carbon dioxide is taken by the algae and we are getting a pure air. So then we thought that why can't we do it then in a controlled atmosphere? So there the challenge was, how will the air go and interact with the algae and come out? So we were successfully able to overcome that challenge. You can see the setup. And now the setup is in the large scale. So these are my students. Now these students have started their own startup called Glow Algaeus. If you want, you can visit their website. It's Glow Algaeus. It's in Noida. So successfully we did this work in our lab, and then now it has become, it has been funded by Government of India also. They funded 23 lakhs rupees for scaling up this for marketing, and now it has reached the market also. So there are corporation, Bangalore Municipality Corporation has shown interest, and there are other municipal corporations also which are showing interest to make it in a large scale. The results are very interesting, and we were able to reduce the carbon dioxide inside the room using this particular technique. The algae could take up the carbon dioxide. It took around near about 5 hours for us to make sure that the inside a closed room, the carbon dioxide level is more. It could come down below the allowed limit. So in cinema theaters and other places where we feel that the air is not there, this could give an aesthetic effect, and we are looking on scaling it up in more higher levels. So the algae and other things, we have patented this. I'm not revealing the results here, and it will be available in the market very soon. There's another product which we have made using algae, that is the algae based filtration mask. So this mask we made before COVID, and during COVID, due to the lockdown, closure of labs, we couldn't take it to the next level. But now it is tested, and we are making the next version, because this version was quite heavy, and we are making the next version. So you can see the algal cartridge over there. I hope all of you can see in the mask. So now the mask which we have made as the second version, it is lightweight and it is transparent actually. So you can people can look at your face, and I have not shown the picture over here. So, and the other thing is, we have a smart fan in this, which makes sure that if the algal efficiency is decreasing, we can identify by the color change, and the sensor will detect and it will inform you to change the cartridge. So this is connected to the interface like phone as well as your watch, smartwatch. So this project is in completion. So it is patented already. I'm expecting the patent to be granted very soon. So these are the work which we are doing in algae. So algae is a wonder which everybody can look on how we can use it. And if we can really tap into it, I think we can make a lot of wonders and miracles. So that's it. With this, I'm concluding. Thank you.
Thank you, sir. Really, you have given wonderful talk on the phytoremediation, and you have used the sentence that really algae are amazing. Yeah, they are wonder. Fortunately and unfortunately, I am the student of Professor B.B. Chougule, who was the well taxonomist in the algae, who has discovered the many algae from Western Ghats. And really, yes, you are using such a wonderful group for the phytoremediation. Thank you, sir. Ms. Mansi, is there any questions from audience?
Yes, sir. We just have one question. That the use of algae, is some study available on the use of algae, whether it is more potential than use of microorganisms for this wastewater treatment?
I think when you compare in the aspects of efficiency, okay, I'm talking about the wastewater treatment, not only in the angle of treating. Then if you see, then we can use chemical treatment also, right? Because they are the most efficient ones. Why have we come to bioremediation? Because we are looking at an angle of sustainable solution. So when you see in that aspect with other microorganisms in controlled atmosphere, if you see in controlled atmosphere, bacterial based treatment is very quick because it has a metabolism which is very quick. Within 18 hours, you can have the maximum growth potential reached. So most of the treatment is growth based treatment. So in that aspect, if you see, you will always go for bacteria. But when you see the other aspect, where in the large environment, if you're going to treat, okay, and you have a multiple angle where not only the liquid waste, you can treat the air pollution also together simultaneously, because we are looking at a sustainable solution. The search for remediation has been always there in a sustainable angle. That's why research is still happening on this. So in that angle, if you see, and at the same time, the possible revenue options. So when you put all those angles, then I would always say that the algae-based treatment would be preferred better than bacteria. But if you ask, I want solution only at a faster rate, and it should be immediately, then all those things that you get instant, you know what is the repercussion of that. So let's be patient, and if that is there, then I think phycoremediation is advisable.
Thank you so much, sir.
Thank you.
Over to you, Dr. Pagare.
Thank you, sir. Really, you have given wonderful talk on this phytoremediation. We could know so many aspects about the algae as a phytoremediation source. Yeah, thank you very much, sir, for joining with us.
Thank you so much. Thank you for the opportunity. I want to thank everyone. Again, the organizers and the organizing committee, and Sandip University, and all the coordinators also for the wonderful opportunity. Thank you all. Take care.
Thank you, sir.
Thank you, Dr. Justin. Thank you, Dr. Pagare, for chairing the session. I would like to invite our next speaker. We will wait just for a minute. And I would like to request again Dr. Pagare to chair the session. Our next speaker will be with us very soon. We will wait for 2 minutes.
Hello, good afternoon, Dr. Srijoni.
Yeah, good afternoon. Good
Yeah.
afternoon, sir.
Good afternoon, madam. I'm Dr. Pagare. I
Yes.
welcome you in our international conference on current trends in waste treatment, reuse, and valorization. Okay.
Yes, sir. Thank
Dr.
you so much,
Srijoni,
sir.
yeah, thank you, madam. Dr. Srijoni, she is working as assistant professor in Department of Biotechnology, School of Life Science and Biotechnology in Admas University, Kolkata. She has done PhD in bioprocess emerging from Advanced Technology Development Center from Indian Institute of Technology, Kharagpur. She has received the National Renewable Energy Scholarship from MHRD, Government of India, for her doctoral work. Worked as a senior research fellow on DSC in Chemical Engineering Department of IIT Kharagpur, and her area of research was quantum molecular simulation. She has done M.Tech in Environmental Biotechnology from University, Jadavpur University. She is having postgraduate diploma in bioinformatics from National Institute of Electronics and Information Technology. She has presented many research papers in national and international conferences in USA, Milan, Italy, China, and she had been awarded with the Best Paper Award for World Renewable Energy Technology Congress, which was held in New Delhi. She was also worked with the ICGEB, one of the prestigious institute of our India, in her PhD tenure. And I welcome Madam. Today she is going to talk on sustainable approach of microbial biomass and biofuel production through the biorefinery approach with the contaminant wastewater remediation. I welcome you, Madam. Thank you very
Thank you,
much
sir.
for accepting our invitation. Thank you, Madam. Yeah, please.
Thank you, sir. Thank you for the introduction. I was there in the conference from morning only, but my laptop got restart just
Oh,
before some time. Okay, okay.
yeah.
Thank you for giving me the opportunity for the presentation. Okay. So I'm sharing my slides. Just a second. Yeah, is it visible? The slides are visible to
Yes,
everyone.
yes, ma'am. Yes, ma'am. You may proceed.
Okay, so I'm Dr. Srijuni. So for today's conference session, I'm going to present one of my means a part of my PhD work and also the research work which I'm carrying out recently. So that is the sustainable approach of microalgal biomass and biofuel production through biorefinery approach with concomitant wastewater treatment. So as we all know that climate change with the increase of greenhouse gases uh, in the atmosphere is currently means defining issue, and the present world is searching for some alternative source of energy as the fossil fuel is getting depleted. Concomitantly, the means wastewater has increased abundantly with the ever-growing human population, which lead to serious environmental health hazards, and also it is mitigating some health problem. So we have to find out. The present world is searching for some way out, the alternative way out, where we can also mitigate the environmental problem, mitigate the greenhouse gas emission, and also can produce a sustainable way of producing energy to meet the whole energy demand. So from there the concept come the renewable energy means integrating with the waste treatment. So as we all know that there are mostly three generations of biofuel. That is the first generation biofuel, that is the agricultural feedstock based. From that feedstock, the biofuel generation started. But there comes the food versus fuel dilemma in a country like India, because in the agricultural land, if we only cultivate jatra, so that is the wastage of time and wastage of land. means in a country like India where most of the people stays in hunger. So to meet the drawbacks of the first generation biofuel comes the second generation biofuel, that is the lignocellulosic feedstock. That is the means we can say it, that is the waste product from the crops, like sugarcane bagasse, rice husk. But what is the problem for second generation biofuel or lignocellulosic feedstock is that means it requires rigorous pre-treatment for the biofuel extraction from that feedstock, and also it has the longer growth time for this both the first and second generation biofuel. So, to mitigate the drawbacks of first and second generation biofuel comes the third generation biofuel. And rather, we can say now at present that is fourth generation biofuel. But let me discuss about the third generation biofuel first. That is the microalgal biomass as feedstock. So why microalgae? So the fourth generation biofuel is the feedstock where the genetically modified microalgal strains are being used for high production. So why microalgae? See, this third and fourth generation biofuel is only consisting of microalgae. So microalgae is shows a faster growth rate than any other plants. So they had the higher photosynthetic efficiency than plants. So it emits less particulate matters. It also the microalgae while doing photosynthesis can sequester CO2 from the atmosphere, and microalgae can be cultivated in wastewater, and we won't require means extra land to cultivate this microalgae. So there comes the no food versus fuel debate is there. So that's why the people is shifting to the towards the microalgal research. So microalgal biomass is very rich in lipid carbohydrate, which can be further converted into biodiesel. The lipid part is can be converted into biodiesel, and the carbohydrate portion can be converted into biohydrogen or bioethanol or biomethane, or we can directly means with the help of pyrolysis we can directly use the microalgal biomass for biogas production. So these are some rich lipid containing microalgal strains, and also means relevant amount of carbohydrate is present in these strains like Chlorella sorokiana, Chlamydomonas reinhardti, Anabenii cyanobacteria, though I put that there because it has higher lipid and carbohydrate content. Then Botrycoccus brownies, Synodesmus obliquus, Neochloris oleoabundans. So there means in these days, microalgal cultivation is wastewater is coming to limelight. So what kind of wastewater can we use for this microalgae cultivation? So municipal wastewater, agro-industrial wastewater, then anaerobic digestion means after the anaerobic digestion in industry, that wastewater can be also cultivated that wastewater can be used for microalgae cultivation. Metal containing wastewater, textile industries discharging some wastewater that can be also used for cultivation. And what will be the nutrients that will be used for microalgae cultivation? So the nutrients which are present in the wastewater is the total phosphate, total nitrogen, trace elements, and some other chemicals or heavy metals which will be used for the cultivation. And further that microalgal biomass will treat the wastewater, means we'll get the nutrient, means after the nutrient removal which will be used for the growth of the microalgae, we'll get a clean water, and from the biomass we can produce the biofuel. So this is the whole concept of microalgal cultivation in wastewater along with the biofuel production. So these are the recent technique where this membrane photobioreactor are being used for this concomitant wastewater treatment and microalgal biomass for biofuel production. Means the power plant is generating, suppose we are taking a case scenario that power plant is emitting the CO2 and the industry is discharging the wastewater that we can use in the membrane photobioreactor for microalgae cultivation, which will finally give the microalgal biomass which will be subjected to biofuel production. So these are the strains specifically used for the wastewater treatment along with the biomass production for biofuel production. So Chlorella sorokiana, Chlamydomonas, Botrycoccus, Chlorella species, mostly Chlorella, because chlorella has higher photosynthetic rate, and it also shows significant amount of higher biomass. Okay, so means what are the different treatment technique of wastewater by the microalgae? So suspended wastewater treatment system is the most conventional way. Here you can use the microalgae, also the bacteria. But the recent one is microalgal turf scrubber for wastewater treatment. So what happens in the microalgal turf scrubber? So microalgal turf scrubber is a recent technique engineered structure where wastewater is poured over the naturally seeded filamentous microalgae. Means rather we can say it as immobilization technique or embedded technique, where the wastewater is poured over the filamentous microalgae that act the same system like turf, and the microalgae treats wastewater by taking up the inorganic compounds and release the dissolved oxygen through the photosynthesis. Then the nutrients, those have not been taken up or scrubbed by the microalgae, remains in the microalgal biomass, growing on the screen or in the form of turf. And the biomass productivity in this turf scrubber is one of the highest that are being reported among all the wastewater treatment techniques. Um, Another one is immobilized wastewater treatment system. Means turf scrubber is also a part of this immobilized wastewater treatment system. So here means this means why we'll go for immobilization system for this wastewater treatment by microalgae, because it is more efficient, it is cost effective, easier processing, means metabolic conversion of wastewater components and harvesting of biomass is much more easier for this microalgal biomass. For this for using this immobilization wastewater treatment system, so that can be of two types, this immobilization thing, that is fixed bed system or the rotating bed system. But up to 92% removal rate is reported by the algae and cyanobacteria on this fixed bed system. So but we will be requiring different types of photobioreactor for the microalgae cultivation. Means whether we are using immobilization system or we are using means for lab scale, means if we are targeting the biofuel after that, so we will be requiring different types of photobioreactors. Because in open cultivation system we can do open cultivation system, but there exists always a chance, means if we are dealing with the single strain, there will always be a chance for bacterial contamination. And the means summer condition is not so favorable for microalgal growth. So photobioreactors or the closed system is always prior to closed open cultivation system. So these are different types of reactor we can photobioreactors which we can use for microalgae cultivation. That is airlift reactor, helical reactor, flat panel. So this is the flat panel. This is a fully controlled bioengineering controlled reactor. Here you can continuously monitor the BOD, COD, means the dissolved oxygen concentration, the pH, the temperature, and the bubble column reactor is mostly used for the industry because the construction cost is very less and very easy to operate. So this is the internal LED light illuminated control reactor. So here the LED lights which are used for the cultivation of the microalgae is submerged in the media, so that the light can distribute very properly. And this is means a larger scale, 20 liter, and it can be also further scale up to 50, 100, means based on the situation. So let me discuss first about one case scenario which was being published in 2021. Okay, so this is a sustainable approach for the treatment of poultry manure and starchy wastewater, which was being collected. That starchy wastewater was being collected from the IIT Kharagpur hostels, and poultry manure is collected from a nearby poultry. So that means a sustainable approach was being developed for treatment of this poultry manure and starchy wastewater in a single process by integrating dark fermentation and microalgal cultivation. So what means this is a two-stage process. So what happened in the first stage, that biohydrogen was produced by dark fermentation using starchy wastewater and poultry manure as a co-substrate. That was being done in a double jacketed reactor. Okay, and in the second stage, what happened, that bioremediation of the organic content in the spent wash, which was achieved from the first stage, will be used for the cultivation of microalgal strain, that is the Chlamydomonas reinhardtii. Here we use the Chlamydomonas reinhardtii, means the effluent from the first stage was being used for the cultivation of that microalgae, and the microalgae grows so well in that spent, and it will be followed by subsequent utilization of that microalgal biomass for biodiesel production. So these integration of the process enhance the overall energy, and it also enhances the sustainability of the process. So now, coming to a very specific thing, that is means up to this I am discussing about the different wastewater treatment techniques, what are the approaches can be done, but means very important part is the fuel extraction from the biomass, and how we'll develop a biorefinery approach. And no process is industry ready without doing any life cycle assessment of the process. Okay, so why industry will take my process? So here I am going to discuss about the transesterification technique, that is the fuel extraction from the biomass, how sustainably we can do that, or make it much more greener, and how we'll do the life cycle assessment of the process. Okay, so biodiesel are the monoalkyl esters of long chain fatty acids that are being produced by transesterification reaction. And what are the advantages of this biodiesel? So it reduces emission of carbon monoxide, hydrocarbon, and SOx. So it has higher CTED index, it has higher flash point, and we require no engine modification to use this biodiesel in the present existing automobile engine. So we all know that different types of catalyst is being used for this transesterification reaction. Means transesterification reaction means we are getting the total lipid, means we are extracting the lipid, intracellular lipid from the microalgal strain, which will be further converted into biodiesel. So that process is the transesterification, and for that we will be requiring different types of catalyst. So the most conventional thing is most of the industries up to this time are using acid catalyst and base catalyst, but there are some drawbacks for using this acid and base catalyst. That is the means acid catalyst can corrode reactor, and that is also not reusable. And base catalyst means if the free fatty acid content in the lipid is much more, the base will react with that free fatty acid and it will produce saponification. So much more so formation will be there. That's why the biodiesel yield will be less, and it is also not reusable. So in recent days, the concentration is being shifted towards the nano catalyst that can be used in the transesterification reaction, because the nano catalysts are sustainable and that is reusable. And it also have some properties like it has the higher catalytic activity, larger specific surface area, high resistance to saponification. So the outline is that, means here means this is part of my PhD work, that means where I use the neochloride soluble strain. So newly developed nanocatalyst, that is the iron oxide nanocatalyst, that was being synthesized in a green process from a leaf extract. And that catalyst, that synthesized catalyst from a leaf extract, was being used for the transesterification reaction, and the process parameter was being optimized, and finally the life cycle assessment was done, and Aspen plus process simulation showed that the theoretical yield is much more similar with the practical thing what we are getting. That proves the industry ready process it can be. Okay, so the first in a first stage, the microalgae was cultivated in the bubble column reactor by CO2 sequestration. So it was observed that CO2 concentration of 2.5% volume by volume CO2 air mixture was being suitable for this strain, and we are getting biomass concentration of 2.56 gram per liter in a 2 liter reactor scale with the lipid content of 49% weight by weight. So that after the cultivation, the microalgal biomass means, here I want to mention that microalgal harvesting and drying cause the major section in a biodiesel production process from microalgae. So if we can reduce the drying and harvesting cost, the microalgal biodiesel production can be commercialized. Okay, so means if we can omit this drying stage. So here means I'm going to present a concept where we can directly use the autoflocculated harvested microalgal biomass in wet form for directly for the transesterification. So autofloc means by the autoflocculation technique, means by just have to adjust the pH, and it will create the flock formation of that microalgal biomass. We can see from the picture that flocks are settled down, and we will discard the supernatant, and we'll use that weight biomass directly for the transesterification. So the maximum flocculation efficiency of 94.51% at pH 13 was observed within 13 minutes of time. So then the microalgal, that wet microalgal biomass will be subjected for different types of pre-treatment, that is ultrasonication, autoclaving, and microwave irradiation. So after all the pre-treatment, it was observed that autoclave pre-treatment shows the best result as it gives back 56.5% weight by weight of lipid after the autoclave pre-treatment we got. So the nanocatalyst, the green nanocatalyst, which was being synthesized from the leaf extract of Hibiscus rosa sinensis leaf. So this was the first report of extracting the iron oxide nanocatalyst from Hibiscus rosa sinensis or from any leaf extract. And the nanocatalyst was being characterized by doing the FSM analysis, TAME analysis, XRD pattern analysis, and it shows similar kind of nature with the iron oxide. Means it's similarized the characteristics of iron oxide nanocatalyst. So that green synthesized nanocatalyst is now used for the biodiesel or the transesterification process. So means we have compared the result, means that is the means three transesterification process where HCl, NaOH, and iron oxide was being used, and it showed that 81% biodiesel yield was obtained using the iron oxide particle as catalyst, and that was higher from HCl and NaOH. So further optimization was done with that iron oxide. So the catalyst concentration, what will be the nanocatalyst concentration in the transesterification reaction? So that was first optimized, and that is 1% weight by weight of iron oxide catalyst can be used. 65 degrees centigrade temperature we have to maintain, and within the 4-hour reaction time will the lipid can be converted into biodiesel. So that's not the end of the process. Means after the biodiesel extraction or the means after the transesterification process, we have to find out the FAME profile, that is the fatty acid methyl ester profile, means to find out whether that biodiesel is suitable or not for using. Okay, so what will be the criteria? So the ratio between unsaturated fatty acid and saturated fatty acid has to be, the theoretical ratio should be 70:30. So we got nearly 70:28 and 77:22, but the major components of biodiesel is the linoleic acid, oleic acid. So these are the major components present in the biodiesel after the transesterification process. So then the extracted biodiesel was compared with the ASTM standard and conventional diesel, and all the fuel prep properties like kinematic viscosity, density, calorific value, acid value, iodine value, port points, seated number, all those are comparable with the ASTM and diesel standard. So simulation was being done with the Aspen Plus, and it was observed after the simulation process. Means the simulation was done by setting the parameters which we optimized in lab scale. Means whether that can be implemented in the industry, and it resulted that means 90% biodiesel is getting extracted by the simulation process. Means the maximum deviation of 3.5% from the experimental result we got in the simulation result, means which proves the means suitability of the process in industry scale. Then finally the life cycle assessment of the overall process was being done by the Gavi 7 software. Here we have seen the parameters like what will be the global warming potential, eutrophication potential, human toxicity potential, ozone depletion potential of the process, and it showed that means iron oxide, by using the iron oxide nanocatalyst, means all the parameters like whether it can be OGP, eutrophication potential, HTP, anything, it is reducing from the conventional one where the HCl will be used as the catalyst. So how will do the biorefinery approach, means to make the process much more sustainable. So means after the lipid was being extracted from the microalgal biomass, that microalgal biomass was further checked, means whether the carbohydrate or protein content is still there or not. So we have found out that carbohydrate content of the de-oiled algal biomass is near about 20.2% weight by weight. So that lipid extracted algal biomass was then further subjected for the dark fermentation for biohydrogen production using acidogenic mix consortia. And in a separate process, it was subjected for ethanol production by Saccharomyces cerevisiae, and it was observed that 0.612 gram per liter of bioethanol production was achieved from the de-oiled algal biomass, and 485 ml per liter of biohydrogen production was achieved from the defatted microalgal biomass. To summarize this portion, that microalgal cultivation in wastewater with concomitant sequestration can be done. Microalgal wastewater treatment technologies is the recent techniques. CO2 means, here I want to mention another one thing, that microbial fuel cells are the emerging thing which are now getting integrated with the photobioreactor system. Means that is an integrated process where we can use the photobioreactor and also MFC for simultaneously generating the biofuel and bioelectricity by treating the wastewater. Autoclave pre-treatment of wet microalgal biomass is the showed the higher efficiency of lipid extraction process. And iron oxide nanocatalyst that was being synthesized in a green process can be used in the transesterification process. ASTM standard is means the biodiesel properties were found similar to the ASTM standard. LCA study indicates the biodiesel production during iron oxide nanocatalyst is not only the sustainable but also superior of same for biodiesel production. Process simulation using Aspen Plus in result 90% biodiesel yield, that is the maximum deviation of 3.65%. And biohydrogen and bioethanol production from the de-oiled algal biomass can be integrated with the biodiesel production process. So this is the group Bioprocess Engineering Lab at IIT Kharagpur, and means a part of research was also based on the simulation process, whether we can means in a reactor design analysis and hydrodynamic parameter optimization was done by the computational fluid dynamics study, means without means wasting the time and labor and cost of purchasing chemicals, can we just scale up our parameters in lab scale. So that part was done in multiphase CFD lab at Kharagpur. So thank you, I'm open for the question.
Explain all these your experimental things and all in detail. Thank you very much. Mansi madam, do we have any questions from audience for Dr. Srijoni?
No more questions right now, sir.
Yeah. Thank you, madam, for inviting, for taking, accepting our invitation. Yeah. Thank you very much.
Thank you, sir. Thank you for giving me the opportunity.
Yeah. Thank you.
Thank you, madam, and thank you, Dr. Pagare, again for sharing the session. Moving further, on behalf of Dr. Sunil Kumar, Dr. Vinit Kumar was going to present, but due to some technical error occurred, he has shared the audio presentation with us. So we would share that presentation for the audience. So we would be having a break till 2 p.m. and we will be again starting with the afternoon session at 2. So thank you all for joining, and I request everyone to be there at 2 again. We will come online and we will go for further session at 2 p.m. Thank you so much.
Good afternoon, one and all. I am Ms. Muskan Sharma. On behalf of School of Science, Sandip University, Nashik, and Society for Green Environment, New Delhi, India, is pleased to welcome you all back for the afternoon session of today's e-conference on current trends in waste treatment, reuse, and valorization. I feel happy to invite our first expert, Professor VP Sharma, Chief Scientist and Professor ACSIR at CSIR Indian Institute of Toxicology Research, Lucknow, and Dr. Razia Kutti, Head of the Department of Microbiology and Life Science at Sandeep University, Nashik, to chair the afternoon session. I request Dr. Kutti to introduce our expert. Good afternoon. Just a minute.
Good afternoon, Dr. VP Sharma. Welcome to the conference.
Very good afternoon.
Uh, Dr. VP Sharma doesn't need introduction at all, I think. His credentials are so many that the time is not sufficient to do justice to his achievements. Dr. Sharma has been awarded Fellow of Academy of Environmental Biology. He is member of many prestigious national as well as international societies, and his contributions in the area of polymer toxicology, water quality monitoring and management has been recognized in different ways. He has contributed as expert member for the finalization of Indian Pharmacopoeia guidelines for primary packaging in PET plastics and also as technical advisory committee constituted under the child labor. He has two patents. He is recipient of several awards, member of several academic societies, and he has been serving as a resource person for universities, and he has contributed extensively to the publications, chapters. He has completed various projects under the umbrella of DOE, ICMR, DST, CPCB, and he has been an international achiever. He has been awarded the Gold Medal for Academy of Environmental Biology. He is recipient of Healthcare Excellence Award, and his contribution in non-scientific areas, which is the societal mission programs. Example, super cyclone in Orissa has also been recognized, and they are quite significant, and has brought several accolades to CSIR IITR. He is a good teacher besides a scientist, and he has also provided leadership training programs and contributed in wide ways to the activities of CSIR as well as in collaboration with other Northeast academies. I welcome Dr. Sharma, and we are looking forward and very eager to hear you at this conference.
Very good afternoon, Dr. Razia. And I would also like to say that it is a great achievement of the Sandeep University in the infancy stage to have the International E-Conference, and that too of such an important topic that is on current trends in waste treatment, reuse, and valorization. So I personally say a great word of compliment to you and to all the team
Thank you.
members who are associated with this wonderful event. Thank you for the introduction which you have given. I think the more important is how we can go ahead to save our country, to make the world a wonderful picture, and putting the things into the right shape. I take these words with the words of inspiration from Dr. Razia and others. And in the morning, I was able to hear the words from the Vice Chancellor, which were very, very inspiring. And I wish all the best to the prestigious university, which has come up and growing like anything. So now coming to directly to the topic, are my slides visible to you?
Yes,
Are
yes.
my Are my slides visible?
Yes, sir.
Once the slides are visible, can I know, Dr. Razia?
Yes, sir. Sure. Yeah, go ahead.
Okay. When I say the word safeguard future generation and we think about the emerging pollutants and waste management, I would like to segregate the few of the things with a wonderful picture in between that we all are looking for the sustainability, the greenery, the good water, but at the same time, there is a threat from the new type of pollutant. As a toxicologist, I would like to say that toxicology is a wonderful interdisciplinary field, and this is the toxicity. When we say it is the dose which differentiate between a drug and a poison. For example, the sodium chloride is very vital and we take in the food daily in the different routes and different systems. The concentration of sodium chloride may vary, but when we have to take the transfusion, it should not be more than 0.9%. So, when we see all these things in the current scenario of this important conference, I need to emphasize that first of all, the water, clean air, the we are needing at the different stage, and the healthy food. But when we see for the aspects of the different biosystem, it may be terrestrial, aquatic, the direct and indirect human effect. And when we talk about the regulatory aspects, there are several parameters in toxicological studies. These may range from acute toxicity, acute oral toxicity, dermal toxicity, inhalation toxicology, ecotoxicology, and what we are looking for? We are looking for a healthy environment. And when we think about the issues, I just want to flicker in the minds of all the attendees in this wonderful conference, that it is not only one material or so, but there is a ever-changing, increasing pattern starting from the human pharmaceuticals, perfluorinated compounds, polybrominated diphenyl ethers, the different type of flame retardants, and all of us are very fond of several type of personal care products. Then these contain the different materials which may be directly or indirectly affecting us. UV filters, then the pharma products not only for human beings but for the veterinarians. And thus the veterinary pharmaceuticals is equally important. In the COVID situation and post-COVID situation, all of you have seen that we are using great amount of the different materials, even the zinc or the nutraceuticals or immunity boosters, how they are acting and what is the effect. We have to see, are we really affecting the air, water and soil, or are in we close coordination with animals, plants and microorganisms, and are they working in segregation or in isolation, or they are interconnected. So the holistic approach is needed, and whether it is a city, holy city like Nashik and others, or the areas of Nagpur or any part of the world, we find there might be the concentration of the pollutants may differ from area to area, river to river, or into the different bodies. And thus we have to think about, are these what chemistry wise or chemical nature wise, are they inorganic, physical, or there are organic pollutants, and there are new chemical entities which are coming into the system. Thus there is a voluminous literature nowadays coming up on new chemical entities, the matrices, the different speciations, and how they really work upon. So we have to think about that, are these emerging from our lifestyle, or they are from the environment, or they are an integral part of the soil, water and others. So these conventional and non-conventional processes also lead, what we really need to do, we have to learn to live with them. We have to learn how we can reduce, how we can minimize, and how we can have the system of bioremediation and others. Fortunately, the Dr. Vineet Kumar, who is an expert in the different fields of related to the pollutants, bioremediation, and published a lot of voluminous literature, it becomes very important to understand that how the India can be Atmanirbhar and be sustainable, and at the same time fill up their gaps for the SDG goals fulfillment by 2030. So, if I just focus on this, you find there is a cross web between the social, environment, and economic aspects. There are ranges of bearable, equitable, viable. What is viable? And what is really sustainable? Because sometimes we get a request from our manufacturer industrialist that my product is biodegradable, it is 100% degradable, but when we go for ecotoxicological tests and others, we find it doesn't suffice with the regulations and the regulatory aspects. So it is vital for us to understand that how we can go ahead. The persistent emerging pollutants are critically issue of great concern due to distribution in varied matrices and omnipresence. The biosystem and the environment are profoundly at risk due to the availability of new chemical entities or their metabolites, including transformation byproduct, whether it is pharmaceuticals, microbeads, nanomaterials. We are thinking about personal care products. So these slides tell you about who and what is the concentration, what are the drugs, whether we are going for the efficacy, how they are affecting the ecosystem, what are microbeads, microplastics, personal care products, and are they really affecting the fish, birds, and other aquatic systems. We really know about good things about nanomaterials, nanoparticles, but there is another picture of it. That is, they may be 10 to the power minus 9 to 10 to the power minus 7, and can be composites, coatings, electronics. There are different materials which are, we saying that, items of choice. Big data, artificial intelligence are supporting in the new R&D areas. What are the adsorbents which can really be helpful in the case of the pollutants to be engraved to the adsorbed? There can be carbon nanotubes, graphenes, there nanomaterials, composites, biochar. You might be hearing a lot of literature on biochar. Good publications are nowadays coming on biochar, and there is an issue that how we can have this organic carbon framework. Okay, what is the circular economy? Can we really go for the system where it can be leading to value additions at the same time minimizing the pollution? So we have to understand what are the advanced techniques for remediation of the polluted water, soil, air, and other and medias. And there can be different type of systems. There can be different type of methods ranging from adsorption, oxidation process, nanofiltration, or reverse osmosis, or there can be a combinations. So we can't talk in isolation, and we have to think that how can really go ahead for all these wonderful materials. This dynamics of food or drugs, the chemicals, and the most basic reason and how we can do is that the prevention, minimization, reuse, recycling, these looks very wonderful, but in practicality we find there are many issues which are an issue of concern for regulators, for stakeholders, for the students, academicians, and the nature lovers, or I can say environmentalists. So there are limited bioremediation techniques, and are they really cost effective? Because in the country like India or the developing countries, we also find that there is an issue of implementation of the right technique at the right place. There is a need of being all these techniques should not be just promoted for the publicity or others, but they should be really implementable, and it should be cost effective so that it can go at the root levels, and we can really have the energy recover and the proper disposal of the systems. So what is most favored and what is least favored, you have to think about from that point of view. One very good thing which we are finding at the present area, that urban areas and peri-urban areas, or rural areas and peri-rural areas, what do you mean by this? It is really to understand that do we really want to go for the organic farming, or spend the evening or the weekend at the farmhouse, or we want to rush from the rural area to the urban area for marketing, for different purposes. So it is not only the term industrialization, but I would say the three P's are interconnected. What are these three P's? These are population, pollution, poverty. And we find that they affect the quality of the environment at the different levels. It is not always degradation, but there can be evolution. But at the same time, in some of the cases, we find, like in case of plastic and polymers, the different type of chemicals, which are ultimately going to the water bodies or the aquatic system, and thereby they affect the organisms or the flora and fauna not only on the terrestrial but in the aquatic system. So we have to understand that are we really affecting these the moieties which are reaching to the aquatic bodies. Another term which is very common nowadays is about the use of the pharma products or the antibiotics. The antibiotics are taken by the human beings, but ultimately through the defecation system and others, they lead to the water bodies. So the active pharmaceutical ingredient, what is there, what is the concentration, which particular antibiotic and others they are reaching to the system. All of us want to see the good, wonderful environment, green environment, and our eyes feel very relaxed when we get up in the morning and we take a round in the nearby area or a park or in our lawn. But we have to understand, are we not polluting it by through our modes? Even if you find the waste disposal of your own house or your locality or the city, you find we are dumping lot of amount of these chemicals indirectly or indirectly. Some of them are persistent, some may be degrading, but at a very slow rate. So it is not only the effect, or it is not that how we are detecting. So I would like to say monitoring and management should go simultaneously. The improvement of the detection techniques through the GCMS, HPLC, AS, ICP, we have wonderful techniques in the R&D areas, and India is not behind, and we are at equal terms in some of the cases with our developed partners or friends in US, UK, Germany, Japan, or in other countries. So what we have to see that this has led to the identification of increasing number of pollutants and these transformation products from where they come. What are these bodies? And these emulsified vegetable substrate, which may be blending at the different levels with the nutrients, vitamins, we have to understand. Another story I would like to share with you about the use of the perfluoride alkyl substances, and there is a group of industrial chemicals. These include the PFOs and PFOs, OS, the BPA, bisphenol A. In the OECD, there is a demarcation, there is a inclination, there is a studies which go according to the good laboratory practices, good clinical practices in the case of pharma, and good manufacturing practices. We have to understand what does this good GLP, GMP, GCP mean. And in our own country, I would like to say that we should follow the Quality Council of India directions or the NABL ISO 17025 in the different laboratories for the monitoring, for training, for capacity building, and to make this one world a wonderful world. Place earth to, because this earth will not be regenerated again and again. We have to care for the future generation. The For the World Environment Day, 5th June 2022, the theme is Only One Earth. Focuses on living sustainability in harmony with nature. Fortunately, this is a week of Science, National Science Day celebration in India, and throughout the world, we always focuses on scientific temper. I would like to say that when we have to think about the National Science Day, the Environment Day, or any other celebrations, we have to think, are we not polluting? What care should be taken, and how our capacity can lead to the betterments. So now it is not just the end. I would like to say that it shows it is just a simple figure, but it says, we may say the great words of appreciation to the country, to the beauty of the different plants and water bodies. But you find that the drain which is here may be not so clean as we expected. So we have to think about the air, about clouds, the wonderful river, as well as the water bodies. And when we have to think about these points, I would like to more and more emphasize that there is a need of proper characterization by the state of art hyphenated techniques which are available for the different type of pollutants like endocrine disrupting chemicals. There can be phthalic acid esters, and even in phthalates there are dibutyl phthalate, there's the DHP. These are more of concern because of the chemical intricacies and their toxicity. The bisphenol A. Earlier we used to say about the bisphenol A, but now we have the different analogs of BPA, which may be through the polycarbonate bottles or different other plastic materials, and they can be above than the permissible limit. So once they are above than the permissible limit, that is an issue of concern. So the disinfection byproducts, for example, we say chlorination is good, but superchlorination is not demanded. Pharmaceuticals, personal care products, everyone wants to look beautiful with the less shrinkages or the linings on the faces and others, but we have to take care of the what are those persistent organic chemicals, nanomaterials. Then another issue is of burning off the plastic and polymers leading to dioxin furans, the microplastics which may be as a degraded products and ultimately our oceans and water bodies, and even ultimately they may reach to the fishes and so forth. So we have to think about the food web with variable toxicological implications. These regulatory agencies, whether it is EPA, WHO, ATSDR, the CPCB, State Pollution Control Boards, and others, we have to think how we can have a networking, better and better output, and also the guidelines which are framed by OECD or ISO, they should be complied for the betterment. And these interventional approaches for preventing and efficient monitoring will help in reducing the adverse effect of the environment and making the flora and fauna effective with happiness. And thus, the keywords which help us to understand all this is about what is persistent, how they are persistent, can they be degraded, what are the techniques, are these techniques readily available, what is the cost, and is it the operation is easy. It should not be very cumbersome, and our students should be well trained to understand how to monitor, how to do the things and analyze the thing with the right concentration. So the precise and accurate, these words become very important when we think about the quality management system. And this quality management system is not at one end or in the laboratory. I would say it starts from the home and it goes to the universities, it goes to our food centers and all our system, whether it is the manufacturing of one product or the other. With this wonderful aspect and opportunity which was given to me, I would like to re-emphasize that the terms like recycle, reduce, recover, how we have to think about it, redesign about it, these becomes very important. And thank you a lot for your valuable time which has been given to me for sparing in this particular moment of international conference. I know various speakers as well as our young students are very enthusiastic, inquisitive to share their wonderful experiences. So I minimize my words with these and say a wonderful year ahead and era ahead with lot of prosperity, success, good sustainability, and all the dreams may come true in the coming years. So let us protect our future generations. Thank you a lot for your patience hearing. All the best once again. Thank you.
Thank you, sir, for your informative talk and for the wishes you have uh, led for us. And I would like to thank you for all your contributions which have paved the way for we youngsters and has given us a direction to go ahead with the emerging pollutants, particularly the nanoparticles and other toxic industrial pollutants, and also your information about the setting the guidelines, etc., has really led us to a thought of a different perspective, and hopefully the future generations would gain advantage of this information from you. And it was a wonderful talk. And I have one question regarding the nanoparticle as emerging pollutant.
Yes.
When we are thinking of the wide applications being uh, like in case of the cosmetics, in case of the pharmaceutical company, in case of medicine. So is there any categorization of nanoparticles based on their toxicity? Is there any threshold limit decided
Yes.
so far?
I would say it's an interesting question, and the answer is not very, very clear at this moment. But the
Okay.
efforts are in progress. For example, with the titanium salt, TiO2, zinc oxide, and other materials, even silver particles, and so forth, the studies are in progress at global level. And in India, the directions have been, or the guidelines have been framed for the nanomaterials. And with the toxicological perspective, the more and more the studies which is ranging for the various parameters including the genotoxicity, ecotoxicology, other are in progress, and there is a baseline information being developed. Even the new databases has come up, and we would like to share wherever, and you can always utilize the facility of Indian Institute of Toxicology Research, where we have about 49 to 50 scientists working in the various fields, and you can take the advantage not only of this but all the CSIR facility who are working in the different era. For example, there are laboratories not only in CSIR but in ICR, DST, DBT, and we are in close coordination even in the medical institutions. The some R&D of great importance is going on. And when I say about the dose levels, the I would say we should make a progress but drive with a caution. And what Dr. Razia was saying, she is right in the way. And in the earlier discussions with Dr. Vineet and others, I would like to say that we have to be progressive, but we have to use the quality product, and we have to judge the product as per the regulatory norms, and not only of one country, but at the global level. Because now no country is single in itself. We have to play a holistically approach. So with these words, I would conclude. Thank you.
Thank you, sir.
Thank you a lot once again.
Thank you, Professor VP Sharma. Thank you, Dr. Kutty. I now would like to invite our next speaker, Professor Dinesh Yadav, Professor Coordinator at Center of Genomics and Bioinformatics and Nodal Officer, IPR Cell at Deen Dayal Upadhyay, Gorakhpur University at Gorakhpur, Uttar Pradesh, and request Dr. Kutty to please introduce our expert and chair the session.
Welcome, Professor Dinesh Yadav. Dr. Dinesh Yadav has more than 21 years in teaching and research, and he has held various senior positions at reputed institute. He is presently the coordinator for Center for Genomics and Bioinformatics and Nodal Officer IPR Cell DDU, Deen Dayal University, Gorakhpur, and he has also served as a head Department of Biotechnology, DDU, Gorakhpur University. He has contributed widely to the area of agriculture and technology. His PhD is from G.V. Pant University, Pantnagar, and he has received various awards and fellowship. He has availed the DST Broadcast Fellowship from Australian Centre for Plant Functional Genomics, University of Adelaide, South Australia. He has also received Dr. Pushpendra Kumar Gupta Vishisht Krishi Vaigyanik Puraskar in the year 2015 in the field of agricultural science, and he has more than 130 research publications in the form of books, chapters, reviews, proceedings, and he has also deposited the sequences, and he has more than 230 accession numbers in the gene bank. He has completed various projects from the funding agencies like DBT, UGC, UP Council of Agricultural Research, Lucknow, and also guided various PhD students, postdoctoral students under various programs, and he has also contributed widely to the various research areas by being editor and reviewer for various national and international journals like Journal of Experimental Botany, Planta, Process Biochemistry, Molecular Biology, Reports, Plant Systematics and Evolution, and he is also an expert in the area of proteomics, computational life science. I welcome Dr. Dinesh Yadav, and we are looking forward to hear from you, your research, and also gain valuable experience from your talk. Thank you.
Thank you very much. Am I audible? Hello. Am I audible? Could you please whether I'm audible or not? Anybody?
Yes, you are audible, sir. Yes, you are audible. Please go ahead, sir. Can hello? Hello?
Hello.
Hello? Yes, now you are audible. Hello?
Okay. Actually, I'm trying to. Hello.
Your voice is breaking, sir.
Yes, I'm trying to upload this
Hello?
file actually.
Hello?
Hello.
Voice is breaking, sir.
Yes, hello.
Hello?
Is it okay now?
Hello? Yes, now I can hear. Hello?
Okay. I'm just
Okay.
waiting for the slides actually.
Yeah. Just a minute,
I
sir.
think it's taking time.
Just a minute.
Um, Hello, sir.
Yes, hello.
So your voice is audible.
The problem is that I don't know, it's taking time for the upload of this file actually, for sharing. The presentation which I'm trying to share.
Okay, sir. We will wait for the uploadation of the file. Then I'll share
Yeah.
it. Okay.
Is it okay?
Yes, sir. The file is also visible and you are also audible. You
Okay,
may start
thank
now,
you.
sir.
Okay,
Okay.
thank you very much. So before I start, I would like to thank all the organizers from Sandip University and Society for Green Environment. They have given this opportunity to share the research work, which may not be directly related to the environment, but definitely there is one thing which is important is the enzymes, the microbial enzymes, and they are coming into picture for different purposes when we talk about their involvement to replace various chemical processes with the help of the enzymes. So thank you very much to all of you. Now coming to this topic which I have selected, this is a topic which is cost-effective production of industrially important microbial enzymes using agro waste. So the concept is clear that people are trying to use the various type of agricultural waste for the purpose for producing different types of important things like the enzymes. So what I'm going to do is that I'm trying to give you a glimpse of what sort of work we are doing and how exactly we are coming to this particular thing that how to use this agro waste as a substrate also for production of different microbial enzymes. So hopefully I'm audible, there's no problem. So coming to our ongoing research, basically we are working with two different areas. One area is basically the related to the plant transcription factor, and the other one is related to the microbial enzymes. So I'm trying to focus on the second aspect, that is the microbial enzymes. And in that enzymes also, we are more focused to one particular group of enzyme that's called pectinases. And I will be discussing what sort of work we are doing with reference to the pectinases. This is just the publication for the plant transcription factor. Then when we talk about the enzyme research, everybody, if the students are there, they definitely know that there are basically three dimensions of enzyme research. One important part is the production itself, that how exactly we can try to search for different way to produce the enzymes. And microbes are one of the important sources for the production of the different enzymes. So you have a lot of things when we talk about the productions. You talk about the fermentation technology, you talk about the enzyme selections, you talk about how to modify the strains, and various things, which is a very ongoing process, and people used to adopt this thing to produce, to have a higher production. They try to search for the strains which can give you the production of the different enzymes. Second important thing is the characterization of the enzymes, which is again one of the basic things when we talk about the research or the enzyme research. So these are some of the fundamental attributes of the enzymes which needs to be discussed when we are working with the enzymes. And there are standard protocols are available. Depending upon the different enzymes, you may have a different assay, but these are the things which needs to be characterized. The third part, which is very important for us, for most of the people who are working with the biotechnology or with the recent innovations, that is basically what sort of manipulation, what sort of innovations are associated with the enzymes. So there are a number of technologies are there which is coming up, which is taking, related with cloning and expression, side-directed mutagenesis, directed evolution, metagenomics. So these are some of the recent trends where people are trying to modify the enzymes irrespective of the sources, whether we can go for the modification of the enzyme for the desired features. Now, when we talk about this modification, everybody knows that this directed evolution of enzyme is a very important tool for it. As you know, the Nobel Prize, which was shared with Frances Arnold, she is basically an expert of this directed evolution enzyme. So this is where people always try whether they can attempt for directed evolution of a particular enzyme, and this has been done for a number of enzymes. Though the pectinases, they are not less explored for it, but many of these enzymes, they have been they have been subjected to directed evolution for different modifications. Now, when you talk about this group of enzyme where we are working, it's a pectinases group, and this pectinases groups are basically enzymes which target the pectin. And pectin is a very complex structure which is present in the cell wall of the middle lamella. It's a very complex structure having both the smooth region and the hairy regions. And this enzyme which we are talking basically lies in the smooth region of this target this smooth region. When you try to classify these packages, again, you see there's a lot of enzymes are there. But here we are basically targeting three basic enzymes, the pectinolase, the polygalacturonase, and the pectinolase. There's a difference in the mechanism also, the different types of substrate selection is also there. And there are different aspects, people are working with different enzymes. When we talk, this is the mechanism of pectinylase, pectin methylase and the pectinylase. What we have seen is that pectinylase and pectinylase, they have the same mechanism. So we are basically working with this pectinylase. Why we are working with this pectinases? Everybody has known about this enzyme. This is very industrially important enzyme, and several functions they have been studied. Extensively studied functions are the fruit juice clarification and the retinal fiber, but still you can see there are a number of other features, other functions which people have reported, though they have not studied extensively. One of the important thing which you might be observing here is the wastewater treatment. So this is another important thing when we talk about with reference to the environment. So whether this enzyme, how exactly it could be utilized for the wastewater treatment. I'm okay. Is it audible? There's no problem. If there is any problem, you can just tell me. Now, coming to the spectrum bias, one of the important features why we are working with the spectrum bias is that it has a very unique mechanism. It has got a beta elimination mechanism. It forms 4,5 unsaturated oligogalacturinates. And another important benefit is that it doesn't affect the ester content of the polymer chain, which is specifically responsible for the aroma. So it basically preserves that aroma. And second important thing is that it does not produce the methanol, which is toxic, while the other enzyme produces. So because of these two features, they are highly recommended for the fruit juice clarification. So this could be a very important aspect, and industrially also people are using this. Though along with this pectinidase, they are also using the polygalacturinases. So these are some of the review articles which we have published with reference to the pectinidase. What sort of work we are doing is that conventionally most of us people who are working with enzymes, they are basically working on this the same sort of work. We are also trying to isolate the strains, both which are already available and also from the soil samples, so that we can try to think about their potential for the production of the PNL. We are also trying to adopt the metagenomic based approach, which is a very important thing because you can use the untapped diversity, which is not possible when you talk about the conventional methods. And then it is followed by optimization process by fermentation. It could be either solid state or submerged. Then the purification and the characterization of the pectinases and the enzymatic characterization. The application study which we are trying to do at present is basically the fruit juice clarification and the rating of the fiber and natural fiber. The basis is that if you have an acidic pectinase, so it could be recommended for fruit juice clarification, and if you have an alkaline one, it is recommended for rating of natural fibers. Now, besides this thing, some of the important thing which we are trying to do now is that we are also adopting the bioinformatics and the genomics and the molecular techniques to decipher the genes, the genome wide also, and the specific genes of the pectinases, and we are trying to study with reference to cloning and the expression. Now, as far as the first part is concerned, which is basically the screening, purification, characterization, so we have done a lot of microbial sources, mainly the fungal pectinases. We have isolated pectinases from several fungal, and we have also published this with just the purification part and the source. These are the strains which has been reported, which we have reported. Some of them they are indigenously isolated, 6 of them, and then we have also screened the strains which were available in MPCC, and we have tried to study the pectinase and the PG productions and the characterization along with the applications. So these are the purified pectinases from different strains. This is the PG from different strains, that is polygalacturinase. And this is the traditional things. Whenever you work with the enzymes, you have to try to find out all this thing when you do the purification part. So these are some of the purification chart of the different pectinases and the polygalacturinases which we have worked on. So I will go fast here because this is just this data. Similarly, you can see this purification chart. And these are the biochemical characterization of all these pectinases from different fungal strains. The purpose of this biochemical characterization is that the application depends upon this characterization. Means the pH is one important aspect, as I have already told you. If it is acidic, means you are going to use it for rating fruit juice clarification, and if it is an alkaline, so you are going to subject it for the rating. Besides this thing, you can go for other applications, which we are trying to do that thing also. So this is the rating thing which we have reported, and this is the first report as far as the pectinase is concerned. Because the reports were available from pectinase and PG, but the pectinase involved in the writing of the first report which we have published in Process Biochemistry, along with the fruit juice clarification. We have also we have tried to do this metagenomic approach, and we have tried to see that how exactly we can isolate some of the novel sources from the metagenomic soil, which are producing fertilizers. So these are some of the approaches, a very traditional approach of metagenomic, and we were able to get one of the clone, but still there was some problem when we talk about in terms of expression. Now, as far as this bioinformatic part is concerned, so I would say it's a very straightforward research. The important research, how exactly it proceeds is that you try to retrieve all the sequences which are available in the databases. This is one aspect, and try to do all sort of bioinformatic characterization like homology search, the multiple sequence alignment, phylogenetic tree, motif search, and based on these sequences, you can also go for various structural predictions also. So this is a very traditional approach. The only thing is that if you do it properly, you may get some important insight into the structure, and that could be utilized for both purposes when you talk about the cloning expression as well as when you talk about the structural modifications. So this by this simple way, we have done a lot of bioinformatic assessment. We have done not only pectinase, polycharacter, and bacteria, we have done the same sort of work with other enzymes, which are listed like lipases, proteases, amine peroxidases, and we have published this article. So this publication was solely the bioinformatic based assessment and the characterization of the sequences and that the protein sequences which has been retrieved from the databases. Second aspect is the genome wide, which people are now doing because as the sequence, as the genome sequences are available, so people are trying to fish out these genes because these are multi-gene families are there. When you talk about this pectinase or any pectinases, so what we are doing is that we are trying to fish out these pectinases genes from different genomes. So one important thing is that there are a number of microbial genomes are there, and Aspergillus, Fusarium, and Penicillium. These are the three important genera which has been reported for the production of this enzyme. So what we are trying to do is that the sequenced genome of these organisms could be utilized for deciphering the multiple genes of pectinases. So we are trying to work on this aspect. This is just one report which we have done with reference to the pectinase gene from Aspergillus flavus, one of the genome where we have tried to characterize 7 pectinase genes. We have done all the bioinformatic assessment. We have done the structural elucidation also. And you can see the structural part. These are the structures which we have predicted, the 7 pectinase genes. And this structural prediction was based on the homology modeling, where we have taken the template IQ1QCX. Similarly, we have done the different species of Aspergillus. This was mined for the pectidase genes, and we have done the same sort of work what we have done earlier. These are the structure of the pectidase. And we have also tried to see whether the plant genomes, with how many number of pectinase or pectin like or pectinases are there. So this was one recent report where we worked on 4 different crops and we did an extensive genome-wide assessment of the PG-like genes in Medicago, sorghum, vitis, and orange. So definitely there has been a variability. You can see in Medicago it is 53, in sorghum it is 38, in vitis it is 49, in oryza it is 35. And we did a lot of extensive bioinformatic analysis, both the structural as well as some of the K by K estimation, the divergence studies. All this software, they are available, they are freely available, and we are using these softwares to study this genome wide. So this is just the work on that aspect. Then comes after this bioinformatic analysis, the next part is always whatever you have predicted that has to be validated by labs. And validation means if you have predicted the genes, you have to clone it, you have to amplify them. So the standard protocol of PCR amplification, molecular cloning, and again validation with the in silico characterization we have done. I will give you just for these are the very standard protocol. We are basically targeting the this genomic DNA of different fungal species. We are designing the primers of the pectinases from the sequence which are available in the databases, and we have amplified number of pectinase genes, polygalactonic genes, and pectinase from different fungal strains. We have cloned some of them, and this clone genes were submitted to the GenBank, and these are again we are targeting. For example, you can see this is the recent where we are targeting the Fusarium genome, what we have done is that we are targeting some of the Fusarium species. Earlier we were targeting the Aspergillus penicillium, but later on we started working with Fusarium. And what we found surprisingly, which is important, is that in Fusarium, most of them are alkaline in nature. This is one important. And second important thing is that as far as the catalytic activity is concerned, as compared to the Aspergillus and the bacterialized from the Aspergillus and penicillium, comparatively they have a much higher catalytic activity. Still, that catalytic activity is not what has to be achieved, and for that we need some modification also. So we have worked with this 5 bacterialized gene from Fusarium. We have cloned them. We have determined the structure also. This is the structure you can see here. And we have done a lot of secondary structure study. We have also done some molecular docking related with different types of ligands. And we got a lot of insight regarding the catalytic activity, which is already reported with Aspergillus because the crystal structure is available in the Aspergillus. So this recent in 2022, we got a publication, and that is the molecular cloning and structural insight into the bacterialized protein from different strains of Fusarium. Similarly, we have done amplification of the PG-like genes. We have done designing the primers, amplifications. And overall, if I have to sum up, is that these are the total number of genes and the PCR amplicons which we have submitted. And these are all fungal bacteriaceae. So these are available, and anyone who want to retrieve the sequences and work on, they can definitely use these sequences. Now, the recent work which we started, one is the genome-wide mining of the sequence Fusarium genome, and the second is where we are targeting basically the various soil samples for bacterial and fungal isolate, which has a potential for diverse enzymes. So now we are not targeting just one enzyme, we are targeting for those microbes or those potential microbes from the soil, which has a potential to produce number of different enzymes and which could be utilized for number of applications. So this is regarding the genome-wide analysis. This is again, it is in the process of publication. We are writing the manuscript, so I'm not going in detail, but we have identified 50 genes from different strains of Fusarium whose sequences were available, and we have characterized them extensively and up to the structural part. And the paper is actually in the communication. Now, the second part, which is more important and which is important from the environmental point of view also, people are always targeting that if you are using the waste for a particular purpose, then it is desirable. And since we are working with the enzymes, so we thought that why not to use the different types of agrochemical waste, agro crop waste, or various type of industrial waste for the production of enzymes. So it is already reported that people have produced number of enzymes by using the different types of residues, which is, I think, which is visible also. You can see there are different types of waste, and they are trying to produce it. So that basically decreases the cost of production. So that's why we are referring it as a cost-effective production. These are the reports. You can see the different types of the substrates which has been used, and these all substrates are available. They are sometimes considered as the waste, but you can see they could be an important source for the production of various enzymes. And the production, again, if you try to see, the production is always a very conventional method of solid state or submerged. So one can go for the optimization of these methods by using the different types of the aggregates. So we are working with the bacteriaceae, but we are also trying to use it for different isolates. Recently, what we have done is that, which I was telling you, that we try to take this soil sample for different sources, and we have tried to isolate some of these strains which has the potential for the production of the different enzymes. So this is one recent work which we have done. So we have collected the soil sample from the botanical garden, and what we have done is that we have tried to isolate the bacterial isolates. Around 100 isolates we have characterized, and we have tried to see that what is the pattern of production of the 5 to 6 different enzymes like amylase, cellulase, xylanase, protease, pectinase, asparginase. And we have seen that the way, if you see here, for example, all these strains for producing asparginase, 100% means they were definitely have a great potential for the production of the asparginase. So we have tried to characterize them, these strains. Initially, we got number of strains, but we, based on the production of the number of enzymes, we restricted to 2 of the bacterial isolates. Still, the identification has been done, but we are in the process of writing, so I'm not giving the name as such. and we have done the classical method of identification also. Similarly, we have isolated five fungal isolate from the same soil, which has a potential for production of these six different enzymes. We have characterized them, and one of them we have just identified them, which is shown here, which is the bacterial strain, that is the BG85, and this strain has got a great potential. I'm just giving you the importance here. We have done the temperature and optimum of for all these enzymes which are produced by this strain. So around 40 degree. Similarly, the pH was alkaline. Some of them they were showing acidic also. And based on this, we have tried to use these enzymes, that is the crude enzyme, which is being produced from this strain for a number of purposes. So one aspect was with reference to the retting of the fiber. So a little bit of retting is observed when we talk about the commercial practices is the first one, and you can try to see the mixture of these enzymes. So definitely they are trying to go for the retting, and that too without the EDTA. We have also used this enzyme, which is produced by this strain for different purposes, mainly for the removal of the egg stain and the blood stain from the cloth, and definitely they are showing potential for it. Then we have also tried it for waste management in terms of that we are trying to use it for the chicken feather, how the enzymes they can be utilized there, the same enzyme, the enzymatic mixture from the same strain. So these applications we have tried to summarize here. So to summarize overall, what we are doing actually is we are trying to use the pectinases initially. That was one target, and that too the pectinases from the fungal strains. We are trying to characterize them. We are trying to do the molecular biology of the pectinized, and we are also trying now to use the various type of agro waste for reducing the cost of production of these pectinases, along with some other enzymes, which is important for different purposes. So the future work which we are doing, which is we have already started actually, the cloning, we have done number of cloning part, but the thing is that expression is one important aspect, and expression is the difficult task which we are trying to do some of the pectinizes. And based on this, the metagenomic approach, we are following that approach also. Enzyme emulation and directed evolution, these are the two things which needs to be done actually, and that is very important because ultimately what we are doing, we are trying to go for the directed evolution, and that too for the enhanced catalytic activity and the thermostability. Because pectinized as such, if you talk about the catalytic activity, it is not to that extent which is required. So that is the ultimate target for a research group. So these are the outcome of the entire research, not only in the enzymology but on the plant transcription vector. These are the 12 PhD, 5 PhDs, and MSc projects which have been done for the last 20 years. It's not just 1 or 2 years. And the financial support, again, there are a little bit of financial support from, I would not say very big projects, but definitely these are the students' project, little bit of project from funding agencies like UGC, DBT, and all that. So at the end, I would like to thank all of you. And since we are in the we are celebrating this science week actually. So with this, I would like to thank. If there is any query, definitely I would like to answer it. Thank you.
Thank you so much, sir, for your insightful presentation.
Thank you, sir, for your informative talk on the enzymes which are of industrial significance. And in the current era of genomics, it would be very helpful to go ahead with the information you have provided, and particularly focusing on the industrial enzymes and integration with the environmental engineering techniques, renewable energy system. We would be able to achieve ahead and go further. Thank you for your information and your scientific excellence. Thank you so much.
Thank you. Thank you very much.
Thank you, Professor Dinesh Yadav. Thank you, Dr. Kutty. Now, I would like to invite Professor Razia Kutre to address the audience. And now the session is open for discussion for any type of scientific query about research or any microbiology related queries. Students and the audience can write their questions in the chat box.
Hello everyone. If there is any query related to today's session or any query relevant to microbiology research, molecular biology research, we can go ahead and discuss the current perspectives and the future approaches with respect to techniques or the available information on the sequence, proteins, etc., on the transcriptomics, on the microarrays, and we can continue our discussion. Kindly write your question in the chat box so all of us can uh, participate and give our own contribution in and share the knowledge, as this is the platform which gives us opportunity to take advantage of the expertise of the people joining and share our own experiences with all the students who are present here. Is there any question in the chat box? Is there any chat question in the chat box? If there is no questions, we will go ahead and continue our discussion. I would be sharing. So since the today's session was on bioremediation,
Ma'am, there's one question from the
okay,
audience.
okay,
Wastewater treatment plants that we have, do they use microbes for treatment?
of course, yes, there are several wastewater treatment plants set up in India itself. I would give you one example of Hindustan Organic Chemicals Limited, which had a waste treatment plant set up by National Environmental Engineering Research Institute, NIRI, Nagpur, and they had done a tremendous efforts and achieved significant laurels when they started their waste treatment plant back in the year 2000, and in that treatment plant a microbial consortium approach was being used. The word consortium means group of microorganisms which are compatible in the existing treatment plant and which has been investigated individually. So consortium can be a group of two microbes or more than two microbes, and they are initially studied individually, and we understand their biodegradation potential, and we also do the experiment at individual level before making it or before developing a consortium. So this consortium approach is used in many other research areas, like for example increasing the soil fertility. Also consortium approach is used where the microorganism present in the soil system are able to provide nutrients to the growing plant, and the plants showed significant difference in respect of the growth and productivity, whereas the plants which are not given such kind of consortium do show a slow growth and productivity. So if any more question is there, please go ahead. Is there any more question? What can a residents association?
I'll ask one question from the audience. The question is, how do bioremediation of soil, which is normally present in the environment?
Please repeat the question. Please repeat the question.
How do bioremediation of soil happen, which normally present in the environment?
Okay. So the question is, under natural conditions, how does bioremediation occur? When we are not externally adding any microbes to a soil, how does the natural system function? It is a very good question and very interesting question, because if we look at the origin of bioremediation, actually it is a nature's healing process. What does the nature do? It keeps on healing or keeps on removing the undesired components from the soil by detoxifying the chemicals, by degrading the toxic pollutants. And what does the microbes do over there in the soil? They consume the compounds, they consume the chemicals, they consume the toxicants and survive in the soil. So various kind of phenomena do occur in such natural conditions. One I would term as natural transformation, that is natural genetic transfer. What happens is that, suppose a pollutant X was present in a soil for 2-3 years, and subsequently a pollutant Y was incorporated due to natural condition or due to man-made condition. So when the pollutant Y comes in the soil, the same microbes which were present and utilizing pollutant X now will get evolved, or they gain the genetic information required for degrading the pollutant B. So this implicate that the microbes in the natural soil continuously keeps evolving and getting acquainted and getting evolve and start utilizing the pollutant which is newly introduced. So I hope I'm able to answer your question. Is there any further question?
Thank you, ma'am. One more question is there, that is, how proteomics or genomics can help us in the study of bioinformatics?
Okay. Very interesting question, because the advent of proteomics and genomics have given us a tremendous opportunity. How and why? Let me explain. In previous times, when we had no access to the genetic sequence, no access to the proteomics, no access to the microarrays, we had to do all the experiments physiologically. Physiologically means we had to study each and every enzyme involved in the process. And by studying the enzyme, by carrying out functional assay of the enzyme, we were able to determine whether a pollutant XYZ is utilized or detoxified. Okay. And so the time consumption was more. So if there are 10 enzymes involved in one degradation pathway, all the 10 enzymes has to be studied individually. But contrary to this protocol, with the upcoming of proteomics and genomics, we get the entire reflection of the genes as well as enzyme by conducting merely one experiment. So when we do a proteomic study, we get the entire reflection of all the enzymes involved, all the proteins produced by the bacteria in one experiment. And by revealing the sequence of the proteins, we can go back to the genetic level. Then we would understand the genes involved over there, and then we will bioinformatically can understand what are the various functional activities carried out by that enzyme for a particular pollutant X. So we are steps ahead when we perform proteomic study or genomic study, and we can hypothesize various processes involved at the genetic level, at the enzyme level, at the protein level. So we get a holistic approach, we get a comprehensive and complete understanding of the physiology of the bacteria as well as the removal of the pollutant. I hope I have answered the question.
Thank you so much, ma'am. Now we would like to begin with the oral and poster presentation. So I would like everyone to just wait for a few minutes and we will start with the presentation. So the first participants for our poster presentation is Ms. Bima Kumari. I would like her to please come on board. Ms. Bima Kumari, you can now start with your presentation.
हम्म हम्म Good afternoon to all of you. I am audible.
Yes, you're audible. You can start now.
I am audible.
Yes, you're audible. You can start.
I am audible, ma'am.
Yes, ma'am, you are audible. Am I audible to you?
Yes, ma'am.
Okay, yes, you are audible. You can start with the presentation.
Okay. Good afternoon to all of you. I am Bima Kumari from Baba Saheb Bhimrao Ambedkar University. Today I am presenting oral presentation, and my topic is bioremediation of pyrene by bacterial strain isolated from hydrocarbon contaminated sites. And my topic related introduction. Pyrene is a high molecular weight pH, contaminant pH, and a complex group of chemicals which are great concern owing to their abundant environmental distribution resistant to biodegradation as well as their harmful effect. Bioremediation is one of such recommended treatment options that hold a promise of delivering a lasting solution for the degradation of pyrene pH. The process of bioremediation involves microorganisms mitigating, degrading, and reducing dangerous organic pollutants to the less harmful ones, such as carbon dioxide, methane, water, without an adverse effect. Biodegradation is the process of degrading the high molecular chain of hydrocarbon using bacteria and other microorganisms. The ability of microorganisms to degrade hydrocarbon varies. Some have the capability of degrade aliphatic, and while other can degrade the monoaromatic and polyaromatic resins. These are my method. I have a sample collection from different hydrocarbon contaminated sites, and start screening method. I have 6 bacterial strain which is potent for pyrene degradation. I have used low concentration to high concentration of pyrene, which is 100 to 5000 ppm of pyrene. Stock solution prepared 1000 ppm, 10,000 ppm of stock solution of pyrene. In my performed biodegradation experiment performed in conical flask with the MSA media plus pyrene and bacterial culture incubated in flask, and flask incubated at 37 degrees centigrade, 140 orbital shaker for 30 days in dark place, and checked OT every 7 days and degradation rate calculated, and find out CFU of each strain. These are flask, and these are 6 bacterial strain OD and percentage of degradation, and these are pH value after degradation and CFU count. And LOP9 have represent 6 OD. LOP9 have 6 LOP9 represent highest OD. These are other degradation method: dehydrogenase activity assay by TTC, triphenyl tetrazolium chloride, and the other second one is DCPIP by 2,6-dichlorophenol indophenol assay. In TTC dye method, I have used phenyl tetrazoline chloride with culture and pyrene concentration and incubate at 30 degrees centigrade and 120 rpm for 7 days. After incubation period, red color visualize, and these so represent dehydrogen activity of pyrene. Dehydrogen is activity by strain of pyrene degradation. After incubation period, take OD 480 nanometer and LOP9 have high OD, and these other method DCPIP. I have prepared MSM media and DCPIP concentration and fresh culture and pyrene concentration. These again incubated at 30 degrees centigrade for 7 days and checked color blue to colorless. DCPIP as a redox indicator and the color have changed, and take OD 600 nanometer. Other method enzymatic assay, I have done enzymatic assay 2,3-dioxygenase, catechol, lipase, lacase, enzyme produced by pyrene degrading strains, and these are Gram-Steny bacteria. I have all the negative strain and the shaped cocaine rod shape. These are biochemical tests: catalase, citrate, urease, triple sugar iron, and casein. In my work study, present study is the first reported report demonstrated the utilization of pyrene as the sole source of carbon energy by bacteria. Hydrocarbon remains the most important energy and chemical source as well as most challenging organic pollutant in future. Bacterial strain I have isolated from specific contaminated environment have shown bioremediation potential and such offer a green alternate approach to clean up these hazardous environment pollutant. 6 pyrene degrading strain isolated from hydrocarbon contaminated site. In my current research work, future planning of 16S RNA and maybe novel bacteria strain found and GCMS analysis also done for identified metabolic product, and future result also comparison of degradation rate of different isolated strains. Thank you.
Thank you so much, Ms. Bhima Kumari. Our next participant is Neha Bhagwat. Miss Neha Bhagwat.
Hello, ma'am.
Yes.
Hello, I'm audible.
Yes, your voice is audible.
Ma'am, our presenter is Muskan Sheikh.
Okay, yes, you may start. Yes. Miss Neha Bhagwat.
Yes, ma'am.
Yes, you may start with the presentation. Is it your screen?
No,
This is
ma'am.
your presentation, right?
No, this is abstract, but our presenter is Muskan Sheikh.
Okay. You are Neha Bhagwat, right?
Yes, but Muskan Sheikh and Sai Jadhav.
Okay, okay. Okay, yes, Neha. I will remove you. Muskan Sheikh is the next presenter. Okay, yes, Muskan Sheikh,
Yes,
are
ma'am.
you there?
Just a minute, ma'am.
Okay, Muskan, you may start. Your abstract has been shared in the screen.
Ma'am, can I get a minute?
Okay, yes. Take your time. Hello, Ms. Muskan. You can start with the presentation.
Yes, ma'am. Ma'am, my presentation won't be displayed. Hello. Hello. Hello,
Yes,
ma'am.
Muskan. Yes, you're audible.
Ma'am, our presentation won't be displayed. We have to explain the abstract.
Okay, yes.
Sorry.
Ma'am, we have sent you presentation file in PPT format.
One moment. Okay, just a minute. We are just looking for your file.
Okay.
Miss Muskan and Neha, we are just looking for your file. Until then, we are going to take our next participant. Next participant is Miss Pratiksha Bankar. Miss Pratiksha Bankar, am I audible? Hello, Miss Pratiksha. Is my voice audible? Hello. Miss Pratiksha might be having some technical issue. The next participant is Sheel Ratna.
Yes, ma'am. I am audible.
Yes, yes, you're audible.
Okay. Can I start?
Yes, you're audible. You may start.
Okay. Hello, ma'am. Can I start?
Yes, yes, you may start now. Your voice is audible.
Okay. Okay, ma'am. Uh, Good afternoon to all of you. My presentation topic is remediation and reuse of distillery wastewater for environmental sustainability. This is the introduction. Why distillery wastewater is a issue in current? Because due to shifting from fossil fuel to green fuel, ethanol is a alternate and uh, whole world or our country also focus on the replacing this as a replacing bioethanol for ethanol and as a sorry our country also target to uh, blend ethanol with petrol and diesel to overcome the global warming effect due to the burning of fossil fuel. Next. Okay. Distillery wastewater is considered as a Second most wastewater generating polluting industry after paper record, because during 1 liter of ethanol production about 12 to 15 liter of waste generated. So, and this aqueous waste, popularly known as different name, as like distillery wastewater, spent wash, stillage, distillery slopes, uh, etc. Characteristic of distillery wastewater: it is acidic in nature, dark brown color due to the presence of melanodine, high BOD, COD, and heavy metals and endocrine disruptive chemicals with some macro and micronutrients. So, due to the presence of endocrine disruptive chemicals and micro minerals, uh, it cause toxic effect on the aquatic and terrestrial ecosystem. Next one. Uh, this is the physicochemical parameters of the distillery wastewater. Various study presented variation in the physicochemical parameters as like BOD, COD, pH varies like 2,500 to 20,000, and other minerals like potassium, chlorine, cadmium, lead, and copper are the metals. These metals cause toxic effect in the water bodies and terrestrial ecosystem. Next. These are the list of the some persistent organic pollutants like stigmasterol. These are the characteristics of the persistent organic pollutants that cause toxic effect like genotoxic effect, headache, cough. These hexadecanoic acid are the endocrine disruptive chemicals, and octadecanoic acid are the cytotoxic, causing endocrine disruptive property, cytotoxic, genotoxic, and in skin irritation. Uh, and these are the list of the previously reported toxic pollutants reported in the distillery wastewater. Next, ma'am. And next, ma'am. Hello. Hello. Ma'am, proceed for next slide.
Yes, yes, it is getting changed.
Ma'am,
Just a
next.
minute. Yes, yes,
Just
there is just a little lag in it. It's getting changed. Just a minute.
okay. This is the schematic representation of distillery wastewater contaminants flow and its impact on the environment. As you can see, distillery industry generated wastewater. If this dispose in the land, this cause increase salinity in the terrestrial ecosystem, acidification, structural destabilization, toxic metal accumulation in the soil, reduce mineral availability as like manganese, microbial diversity due to the acidic in nature. It's shifting in the microbes like algae, bacteria and rhizobacteria, and finally productivity and growth of the plant is affected. Further, in aquatic ecosystem, this increase turbidity and cause eutrophication, depletion in DO and photosynthesis, and toxic effect on the aquatic like fishes. As you can see from through percolation and seepage from the terrestrial and aquatic system, it reaches to the groundwater. Through groundwater, it after utilized for the irrigation purpose is and for drinking purpose, it reaches to the mm, human food chain and cause various toxic effect through biomagnification process. Next, man. Yeah, this is the treatment approach for distilled water. As I previously discussed about the toxicity of distillery wastewater. So before discharge into the environment, it's mandatory to treatment. So for distillery wastewater treatment, various um approaches are applied like physicochemical treatment like sedimentation, adsorption, coagulation, oxidation, ozonation, electrolysis, reverse osmosis, ultrafiltration, and nanofiltration. Uh, Further, in as a biological approaches like bacteria, fungi, algae, constructed wetland, and vermicomposting and microbial fuel cell are the applied for treatment before discharge into the environment. But treatment is the only reduce the toxicity. As I previously discussed, beside of toxic pollutant, it's also have some minerals. So it's recovered from this wastewater. So recently, various treatment approaches are applied for resource recovery, which discussed in the further slide. And proceed. Yeah, this is the flow chart. Like you can see how distillery wastewater generated uh, during the ethanol production. Distillery wastewater is treated through the physicochemical approach, biological approach, or it's combinedly. Beside of this approach, this is also treated or converted through the thermolysis or dry into various usable byproducts. But through the biological or integrated approach of biological and physical treatment approach, convert distillery waste into value added product through microbial activity as like biosurfactant, biomass, animal feed. After treatment, due to the reduction of toxic pollutants, it utilized as a ferti irrigation that reduce the utilize of groundwater for um, irrigation and provide together with minerals that present in the distillery wastewater. Next. Yeah. Uh, in conclusion, physicochemical method are more efficient for decolorization and other pollutant reduction, but they are energy consuming, secondary waste generation, and not suitable for the environment. While biological treatment system are eco-friendly, cost-effective technique for the dilution of the distillery wastewater, but demand some modification. Advancement also need an additional nutrient supplement for the treatment. So, solitary physicochemical or biochemical approach are unable to complete management of distillery wastewater. So, the combined approach of the various physicochemical and biological method are applied. So, use of distillery waste as a feedstock substrate not only reduce the waste generation and its treatment cost, which simultaneously provide an opportunity for cost-effective production of value-added products that focus on the three R: reduce, reuse, and recycle of waste. Thank you.
Thank you, Mr. Sheen.
Yes,
Now
madam.
we are going to start with the next participant. Thank you so
Okay.
much. The next participant is Miss Pratiksha Bankar. Ma'am, you may start now. The screen has been shared. Hello, Miss Pratiksha. Your voice is not audible. Miss Pratiksha, your voice is not audible. Miss Pratiksha, there might be some issue with your mic, so we can take the next participant for now. The next participant is Mr. Tushar Shinde.
Hello, ma'am.
Sorry, sir, you may start with the presentation. Your
Audible,
screen.
ma'am.
Yes, sir.
I'm audible.
Yes, sir. Yes, sir, you're audible.
Okay.
Okay.
So, very good afternoon to all of you, all the respected dignitaries. So, this is international conference on current trends in pest treatment, reuse, and valorization. So, my today's presentation is current trends in physiochemicals method of reactive dyeing of cotton fabric, presented by Tushar Shinde and guided by Dr. Sachin Munde, sir, Dean and Associate Professor, Sandip University, Nashik. Please, next slide, ma'am. So this is the content of my presentation: literature review, introduction, objectives, material and method, result and discussion, conclusion and references. Please, next slide, ma'am. So about literature review. So in present research work, cotton fabric was dyed with the light, medium and dark shade of reactive dye. So using red, green and blue color. So in second step, we are followed the fastness properties of the dyed fabric, like fastness to washing, fastness to water, fastness to rubbing, were evaluated by standard method. So after the dyeing, it can be applied to the softening treatment, like we are using a silicone and polyethylene softener, and finally fabric get evaluated into the tearing as well as the tensile strength. So the printing and finishing are the most important aspects about the with fabric concern, like which is to be improve the attractiveness of the fabric, hand feel, handle, absorbency, and wearing comfort qualities. Next slide. Please, next slide, ma'am. So the introduction. So in that research work, we are especially focused on physiochemical process, on effect of finishing chemicals on fastness property of the reactive dye, and evaluation of fastness properties of pigment printed cotton fabric. So the textile material that attach themselves to their substrate as like chemical linkage, the various reactive dyes commercially available and which is applied to the cellulosic fiber, basically from the cotton fiber, the reactive dye which contain reactive groups and it is applied to the fiber by alkaline conditions with the dye bar. So the comparative assessment between the two methods like CPB, that is cold pad batch, and E-control dyeing process. So this E-control dyeing is mostly ecological, economical process of dyeing which was introduced in the dyeing systems which was used in rapidly. Please, next slide, ma'am. So basically, it introduced to provide the textile material in the systems which is rapidly method and basically used for the cellulosic fiber. Basically, it used to the minimum chemical use in that particular process. So the every reactive dyes of cotton, alkali plays an important role that basically used for the depth of shade and the pH of all reactive dye. It is particular not same in that requirement of alkali in different dyes, but dye to dye variations is also as per the shade. So pad dry process dye diffusion exerts more significant, which is influence on that fixation of subsequently the color deal which is to be take place, and the applications of softener is the main purpose, which is improve the aesthetic properties of textiles. So please next slide, ma'am. Please next slide, ma'am. So these are the objectives to optimization of reactive dye using optimization of process parameters to develop the desired shade with respect to that strength of color, to study the defect and remedies in that chemical processing. So modification of the process parameters like telling what we can say that the strength of color, these are identified, and study the defect of finishing chemicals over the cotton fabric by using the assessment of different fastness properties of the dyed or printed fabrics. So materials and methods. So basically, when we used the materials and methods in that particular study, so we used 100% cotton woven fabrics, which is made from that Birla century, and machines that is padding mangle, gyro wash, crop meter, and spectrophotometers for used of to used for that color strength. And method we used color fastness washing, color fastness to rubbing, color fastness to water, and use tensile as well as the steering strength. And we can compare to all these two process, that is cold pad batch dyeing and e-control process. So these are the some chemicals which is used for CPB as well as the e-chemical e-control method. Please next slide, ma'am. So that part B, same materials to be used, 100% cotton pigment printed fabrics. But here we can get treatment about the softener as well as the lubricants. So we have used two different softeners as well as the lubricants. So that is amino silicon softener we have used, and one cationic softener, and lubricant to reduce the friction has benefits to reduce heat generation and the formation of wear particles as well as the to improve the efficiency. Please next slide, ma'am. So now results and discussion. So first of all, color fastness to washing. So color fastness to washing in especially the red color of dye with e-control and CPB method. So here we observe that from the above graph, which shows that the difference between the washing fastness properties of e-control and CPB with respect to that red color of dyes. So as per the graph, we observe that in e-control process, which gives the better washing fastness of all these three shades, we can say that the red color shades, and we observe that comparatively the CPB. So the e-control process which gives the better fastness property as compared to the CPB. So next slide. So second method. So second method is that the color fastness to rubbing. So in color fastness to rubbing, so here we observe that, which shows that the rubbing fastness of dry and wet conditions of e-control dye, which is moderate to give. That means that rating which is represent that the CPB and e-control dye. it can be proper moderate control to both the dyeing process, respectively the fastness property of dry as well as the wet rubbing fastness property of red shade of the reactive dyes. Next, ma'am. So this is the color fastness to washing. So here we observe that in color fastness to washing, in CPB as well as the E-control dyeing of red shade, the E-control process shows that good resting fastness. Okay. So in that E-control process, which gives the excellent results, that is 4 out of 5. So as compared to CPB, and after the dyeing process, which is concentration to the color fastness to water. Next, ma'am. So this is tensile strength. So the tensile strength, as per the graph, which shows that the applications of silicone softener in different concentration, as like 5, 10, and 15 GPL, subsequently to decrease the tensile strength of the fabric, which is to be observed. So that this warp wise, which is decreased in the warp wise as well as the wave wise. So it can be the action of softener into the fabric interface. That's why there are decrease the tensile strength. So next. So here part B, the rubbing fastness. So as per the graph, we observed that in second recipe, we are used to improve the fabric rubbing fastness property. So this is that in wet fastness property, it should be improved to 3 to 4. So the fabric of rubbing fastness, which is to be improved in wet, especially the wet rubbing fastness. And the results was shows in the pigment printed fabric using silicone as well as the polyethylene softener. So these are used to the wet rubbing fastness, which is to be improved. So here, the conclusion of that particular study. So from the above experimental data, it shows that the dyeing process, which is to be carried out using two different techniques, that is CPB and E-control process of respectively red, green, and blue color of shade of reactive dye. Here we observe that, so in E-control technique, which gives good washing fastness property as compared to the CPB process. So the softening process is carried out using silicone as well as the polyethylene softener on the fabric sample various concentration. So in polyethylene softener, which increase the tearing as well as the tensile strength due to the binding effect of the fiber, and silicone softener decrease the tensile strength due to the slippage of the fabric. So these finishing not only improve the rubbing fastness property as well as the fabric, but it can be also improve the softness and feel of the fabric, and the performance is minimized in this work and step towards success to improve the life of knitted fabric. So apply to the special kind of finish. So these are the references we are used. So thank you. So if you have any questions, please. Thank you, ma'am.
Thank you so much, Mr. Tushar Shinde. The next candidate for the participation is Ms. Shwetaja Deshmukh.
Am I audible, ma'am? Am I audible, ma'am?
Just a minute, I'll just share your PPT. Yes, ma'am, you may start now.
Okay. Good afternoon, everyone. Today I am going to present a research paper on decolorization of azo acid orange using textile dye degrading microbes and its media optimization and toxicity study. Next. Textile dyes are mostly made up of chromophore, which is a coloring component, and oxochrome, which is a color intensity component. These dyes are mainly classified into application basis and on their chromophore basis. Upon their chromophore basis, they are categorized as quinone dyes, nitro, sulfur dyes, and azo dyes. Mostly 80% of azo dyes are used in textile and intermediate industries, wherein these dyes are mostly very toxic, xenobiotic, and reluctant to biodegradation processes. In small scale industries, they are left out as it is in natural reservoirs, which can lead to affect the transparency of water, gas solubility in water, which leads to infections and toxicity to the flora and fauna of the natural reservoirs. There are various treatments available for dye degradation waste, that is physical, chemical, and biological. But physical and chemical products, chemical methods can give secondary toxic byproducts, and these are very costly. So mostly we opt for biological processes which are cost effective. Next. Yes, methodology. For the isolation purposes, the samples of activated sludge were obtained from CEPT plant of Tamil Nadu, Vapi, and Gujarat. For isolation, a minimal salt medium was taken, in which 100 ppm of dye was added and were incubated on the plates. After incubation, the zone of decolorization was seen, and these organisms were selected for further screening. There were almost 78 isolates, and from that, screening was done for the potent isolate. For the screening, minimal medium and acid orange was taken, and decolorization in liquid medium was seen, and the hours for it was 10 hours. After 10 hours, if decolorization was seen, then that organism was selected for further usage. Identification was done using Vitek and 16S rRNA also. In media optimization, carbon, nitrogen sources were done for maximum dye decolorization. Critical compounds such as ZnSO4, Cu, Mn, cobalt, nickel, and ferrous were used. The physicochemical parameters like pH, temperature, and inoculum size was also studied for the effect on dye decolorization. Next. For the isolation, almost 78 isolates bacteria were isolated from 3 different samples. And in screening, 1 bacteria out of 78 isolates was found to be very potent, degrading almost 93% of dye. And it was identified as Bacillus licheniformis. For media optimization, we can see that carbon sources, that is glucose, and its optimization of 5 gram per liter gave 94.91% of decolorization. For nitrogen sources, yeast extract of 2 gram per liter gave 96.39% of decolorization. Next. The effect of critical compounds, as we can see that zinc, copper, and ferrous had maximum effect on decolorization, whereas manganese, cobalt, and nickel gave negative effect upon decolorization, which was almost 14% only. For temperature and pH, it was found that 40 degrees Celsius of temperature and 7 pH were optimum for maximum decolorization of 99%. And for inoculum size, we found out that 2% of inoculum size was more than enough for decolorization of medium for more than 99%. Next. After all these studies, a Plackett-Berman design was formed, and we found that the the difference between traditional medium and optimized medium, 93% of dye decolorization was done in 360 minutes. But after Plackett-Berman optimization of the medium, we found that 99.63% of dye was decolorized in 2700 in 270 minutes only. Next. These are the analysis results where in UV graphs we can find UV spectrophotometry graphs. We can find out that the peak for 483 nanometers, which is significant for acid orange, is has been disappeared after the treatment in the side image. And for FTIR, we found out that the stretch of the band for 1543 is disappeared in after decolorization, which is significant that the bacteria has degraded the dye in a very perfect manner. Next. Then toxicity testing of these degraded treated wastewater was done, and from the images we can see that the untreated water, that is really the dye solution, gave only a very less amount of growth in the pot culture, whereas the treated wastewater and control are similar enough. So after the treatment, we can use this treated wastewater directly for other purposes. Next. Next, please. Concluding with the session, I can say that almost 78 bacterial isolates, bacteria were isolated. Out of one was potent, named Bacillus licheniformis. After media optimization, we got 93.36% of dye decolorization in 270 minutes itself. This is the total composition of the medium. And by UV and FTIR results, we can say that the dye is being degraded and not only decolorized. Further, HPLC methods has to be incorporated so that the degraded products can be analyzed. But after toxicity studies, we found that these decolorized or these treated wastewater can be used for gardening purposes or different other purposes. Next. Thank you.
Thank you so much, Ms. Shwetaja. The next participant is Ms. Pratiksha Bankar.
Ma'am, I am audible?
Yes, you're audible. You can start with the presentation.
Okay, ma'am. Thank you. Can you present my presentation? Yes, ma'am. Hello, everyone. My name is Pratisha Rajendra Bankar, and I am from Madhuji College, Fulton. Today, my topic is use of microbial remediation in prevention of soil in microbial remediation. Next slide, please. This is guidance given for me, Department of Chemistry, Madhuji College, Fulton, Satara, MS, India. Authors can be guided me, B.S. Kamble, HOD of Chemistry Department of Madhuji College, Fulton, AP Acharya sir. Microbial remediation. Next, we see the extract. The cleaning up of chemical pollutants from the contaminated soil has been emerging issue for the world, passing threat to ecosystem of contaminated soils at is the process where microorganisms are employed to lower the bioavailability of the pollutant, and this of pollutant. Bioremediation is a biological mechanism of recycling waste into another form. Microorganisms are necessary for effective solution to overcome challenges. For example, microorganisms and the degradation of the compound. We see the, for examples, penicillium and chrysogenium. The This is the abstract. And what is the introduction for our topic? The introduction for this topic is microorganisms are widely distributed on the biosphere because of their metabolic ability is very impressive, and they can easily grow in wide range from the contaminated soils is a worldwide problem nowadays. The presence of elevated levels for chemical pollutants in the soil is pollution. This is potential threat to ecosystem health that has a strong life quality. Ultimately, according to bioremediation, is an environmental friendly recovering the polluted soils. Next, see the image. The recovery of soil takes place by fungi, bacteria, and plants, and this converted into the green earth. This is the bioremediation. Next, please, ma'am. Next slide, please, ma'am. Yes, ma'am. Yes. Okay. Uh, the biological factors are affecting on the microradiation. First biological factor, biotic factors are affect the degradation of organic compounds through competition between microorganisms for limited carbon sources. Antagonistic interaction between the microorganisms or the predation of our microorganisms by protozoa and bacteriophages. The mutation, horizontal gene transfer, enzyme activity, interaction, its own growth until critical biomass is reached, population size and composition. Next, we see the environmental factors for the affecting the microbial remediation. The metabolic characteristic of the microorganisms and physiochemical properties of the targeted contaminant determine possible interaction during the process. The actual interaction between the two, however, depends on the environmental conditions of the state. The interaction biodegradation can occur under a wide range of the pH. However, pH 6.5 to 8.5 is generally optimal for biodegradation. So, moisture influences the rate of contaminated metabolism. Next, please, ma'am. Next slide, please, ma'am. Okay, ma'am. Okay. The advantages of bioremediation, we see it is the natural process. It takes a little time as an acceptable waste treatment process for contaminated materials such as soil. It requires a very less effort can after the carried out in site, often without causing a major disruption of normal activities. Third, it is applied in a cost-effective process as it costs less than other conventional methods. Technologies that are used for sites also helps in complete destruction of the pollutants. Clean up hazardous waste. It is help in completed destruction of the pollutants. Fifth, less simple, less labor intensive and cheap due to their natural in the environment. Six, effective way of remedying natural ecosystem from a number contaminate and act as an environmental friendly option. Next, we see the microorganism and compound. Which microorganism destroy the compound in the environment? First, Penicillium chrysogenium is destructed by the compound monocyclic aromatic hydrocarbons benzene, toluene, ethyl benzene, and xylene phenol compounds. Next, second microorganism is uh, Bacillus subtilis. This destructed or destroy the oil from the soil. Next, Saccharomyces cerevisiae. It is destroy the heavy metals, leads, mercury, and nickel. Okay, next, ma'am. Okay. What is the conclusion of our topic? Biodegradation is a very fruitful and attractive option to remedying, cleaning, managing, and recovering technique for solving polluted environment through microbial activity. The speed of unwanted waste substances degradation is determined in competition within biological agents, inadequate supply with essential nutrient, uncomfortable external abiotic conditions like aeration, moisture, pH, temperature, and low bioavailability of the pollutant. Next, we see the result of our bioremediation topic. What is the result of soil? How soil is converted into non-toxic. The result, by using microbial remediation technique, we can control pollution of soil, destroy the hazardous chemicals. By using fungi, bacteria, plants, the hazardous substance in the soil is converted into the non-toxic or less toxic substances, and the this soil is converted into the pure soil or less toxic soil, and we make our earth is green earth, and the prevented soil from the pollution. This is very easy method for the prevention of this soil. Okay, ma'am. Next, please. Okay, thank you for listening me. And the acknowledgement. What is acknowledgement for this topic guided me? I would express to my deep sense of gratitude my project guide Professor Yajja Saranke, who was giving an opportunity to prove myself in the ever field. I express my thanks to Dr. B.S. Kamre, head of department of our chemistry department support and allowing me to use the facility available in the department. The reference I taken the two reference in this link. And lastly, I also thank you for the University of Sandip University because giving guidance me. Thank you.
Thank you, Ms. Prasiksha. The next participant is Ms. Muskan Sheikh.
Yes, ma'am.
Just wait a few minutes, Ms. Muskan. We are going to share your screen really soon.
Yes, ma'am.
Okay, your PPT has been shared. You can start now. Hello?
Yes, thank you, ma'am.
Okay, yes.
So our topic is biochar assisted wastewater treatment for sustainable agriculture. This whole project it is based on the problem of wastewater, specifically industrial wastewater. As we know, in today's world, there is a lot of wastewater problems, bad and causes health hazards. Ma'am, the next slide. These are my team members. We have conducted this experiment. Next slide, ma'am. Hello. Hello. So as we all know that water pollution is a major problem in today's world, and different kind of industrial discharges, sewage discharges, these cause a major effect on living flora and fauna. Such untreated wastewater can create pollution problem, and it causes health hazards to living beings, also the fishes and animals in the environment. Next slide, ma'am. So, as we know, this is a global problem of industrial wastewater, and as more people, more food, and worse water is a major concern of today's times. It is a global review of water pollution from agriculture, as if such industrial water can be used in agriculture, it can be a great effect for our environment. Next slide, ma'am. So, why is this treatment necessary? It can be helpful in overcoming and reducing the water pollution to a greater extent, as this whole procedure and treatment it is an immediate solution, as it is eco-friendly and can decrease the environmental problem, and also it is the need of this hour. Next slide, ma'am. Hello. The background of this study is the main or major approach of this study was to target the wastewater pollution, of course, and we used the activated biocharcoal from the coconut shell for this treatment as it is eco-friendly and naturally available component. It is also helpful in limiting the toxic components in the industrial discharge and can cause less effects to the environment. We also developed a column by the help of the activated biocharcoal, and use of this treated water can be helpful in irrigation of agricultural crops. Next slide, ma'am. Uh, we took the reference of Langmuir and Friendlich, who introduced us the bioabsorption phenomenon, by which we came to know about the biocharcoal, which is a very great bioabsorbent component, and by the other research papers and others scientists, we were able to create this whole procedure. Next slide, ma'am. The significance or the rationale of our project was to help and get a permanent solution for wastewater problem by the help of waste coconut shells as biocharcoal, and we can help and project out the problems of the polluted wastewaters, which shows an eco-friendly way to help the environment. Also, biocharcoal, it can be employed for the removal of various contaminants from water as well as from the soil. Next slide. The aim of our project was to, of course, investigate the biocharcoal for wastewater treatment and its use in agriculture. For this, we prepared different kind of activated biocharcoal samples, and we used different parameters such as BOD, COD, that is biological oxygen demand, chemical oxygen demand, total solids, total dissolved solids, total hardness, heavy metals, microbial analysis, pH, temperature, etc. We designed the biocharcoal assisted adsorption column, and we also did the phytotoxicity. We will be studying that further in the slides. We also carried out the FTIR method, that is basically for the adsorption phenomenon. Next slide, ma'am. The hypothesis of this study was, of course, to design an biocharcoal assisted wastewater treatment column by the help of coconut shell obtained biocharcoal, and to study the different parameters by the wastewater, that is phytotoxicity studies, which can be further helpful in irrigation of agricultural crops. Next slide. The research and methodology or method of this whole project was to collect the wastewater sample. We detected the pH, temperature. We stored the sample. We prepared and we activated the charcoal by the help of citric acid, that is lemon extracted citric acid. Also by the help of KOH, NaOH, HCl, and other components, out of which lemon extracted citric acid was found to be the best activating agent for biocharcoal and for the wastewater treatment. So we further activated the biocharcoal and did batch study on it. Next slide, ma'am. And of course, we detected the different parameters, that is again the BOD, COD, TDS, heavy metals, total dissolved solids, pH, temperature, etc. Later on, we designed the column. We'll be further studying that and phytotoxicity studies. Also, the FTI analysis was carried out, and further agricultural applications are supposed to be done by our project. Next slide, ma'am. So the preliminary work of our project was collecting these samples. So we collected these wastewater sample from industry, that is the Mahape industrial area. This industrial water, it contained the fats, amides, fungicides, biocides, minerals, oils, and other components, mainly health hazarding components. Later on, next slide, ma'am. After checking its temperature and pH, we found out that these industrial water, it contains lot of health hazarding agents. So our main major work of this project was to decrease such components and clean this water, or I can say detoxify this water, which can be helpful in agricultural uses. Next slide, ma'am. Also, the preliminary work contained the preparation of biocharcoal. For this, we collected the waste coconut shells and we burned them, or we performed the pyrolysis by burning them on high temperature, and we converted this charcoal on the stove or chula, and we obtained different consistencies of biocharcoal, out of which about zero point 0.1 mm of charcoal was found to be the best out of them. Next slide, ma'am. Later on, the activation of biocharcoal, as I said, we used different chemical agents, that is lemon juice, extracted citric acid, HNO3, NaOH, HCl, KOH, etc. About 50 grams of biocharcoal was added in 1 liter of this flask of waste industrial waters. We put them on shakers and we checked each and every parameters, that is BOD, COD, TDS, pH, temperature, and out of which, of course, lemon extracted citric acid gave us the best results for activating our biocharcoal. Next slide, ma'am. This is how we perform the activation of our biocharcoal, putting them on shakers and filtering out the drained water. Next slide, ma'am. Later on, we conducted the wastewater treatment, that is batch study. That is, we took about 1 gram of activated biocharcoal in each conical flask, about 1 gram of charcoal per 100 ml of waste industrial water. Next slide, ma'am. Hello. Next slide, ma'am. Hello. Then we detected these different parameters again, and out of which performing this whole experiment, and we found out that next slide, ma'am. We found out that before treatment, the parameters before treatment and after treatment. Next slide, ma'am. And here, after treatment, we can see there is a major difference before and after sample, after it was treated with biocharcoal. Next slide, ma'am. And this is the treatment after activated biocharcoal, that is by citric acid, lemon extracted citric acid. As we can see, most of the controls test, other biological oxygen demand, chemical oxygen demand, total dissolved solid, all of this showed the best and near to permissible limits values. Next slide, ma'am. These are the permissible limits, and we can see they are much more closer to that. Next slide, ma'am. Hence, this is how we perform the whole different parameters. Next slide, ma'am. And of course, our major work of concern was the design of column. For this, ideally, we had to prepare a column from waste. So we took a waste plastic bottle and we cut the lower parts and we inverted it in the conical flask. We attached a muslin cloth. We added about stones, grass, are activated by charcoal, Wattman filter paper, and we filtered out the water. And the results, they were very good after this treatment. Next slide, ma'am. This is our column on a smaller scale. Next slide, ma'am. Later on, we conducted the phytotoxicity studies, which concerned the germination and potted plant method. This is the germination method. Here we found out that the treated water sample gave us good results than the untreated water sample. Next slide, ma'am. And the wastewater, as we can see, for the phytotoxicity test, the potted plant, that is, we again used the waste plastic cups, and here we can see the treated water is giving us much more better results than the untreated water. Next slide, ma'am. The expected outcomes of our project were to decrease the pollution problem and to use it for irrigation of agricultural land and to overcome the scarcity of water and recover the water. And also this water can be used in agriculture and water sustainability processes. It can be a reduction in water pollution, and after this whole procedure the water can be available all year round, and hence use of this biocharcoal in soil can also have a good and positive health effect. Next slide, ma'am. Benefits to the society. Of course, the major concern of our project was the benefit to our society. It is that it can clean the water, it can give us a non-toxic, safe and clean water after the treatment. Also, it is eco-friendly, cost-effective, and detoxification of industrial water can be taken place. This water can be used in municipal and other industrial or domestic purposes, and it can help to reduce the toxic pollutants from our wastewater, and it can be used for the flora and fauna. Next slide, ma'am. Our cost effective or benefit analysis was, as we can see, less than 2000 rupees were used for this whole project. These are like negligible prices, like our coconut shell, lemons, and other column material. These were obtained from the waste. Next one. Slide. The future work of our project was to carry out FTIR analysis and bioabsorption kinetics that we have performed, and after which we have found out that the functional groups which were responsible for our biocharcoal to be activate, or we found out that it gave us better results in that way. Next slide, ma'am. SWOT analysis, that is the strength, weakness, opportunities, and challenges of this project were. It is an eco-friendly way or eco-friendly project. It can be helpful for the farmers and for the agriculture. It is very simple and very cost effective, as we have seen. The opportunities of our project is that the farmers can use this column for the wastewater treatment and agricultural irrigation. The water scarcity issue can be solved, and a natural and ecological balance can be maintained. A large amount of biochar will be required. That is our weakness, and it is a time consuming process. The challenges are on-site application and training the farmers. Next slide, ma'am. So these are our references, and we can see that if such columns were to be established or to be formed in industries, and industries will pass their industrial discharge through this column, it can be a very effective method to clean the water before it enters the rivers or lakes. Hence, a clean water can be obtained. Next slide, ma'am. Thank you for letting us present our project. Ma'am, we are done.
Okay, thank you so much, Muskan. Next participant is Tabassum Siddiqui. Hello, Ms. Tabassum.
Yes, ma'am.
Okay, you may start now.
Good afternoon, one and all. Myself, Tejas Avari, and myself, Tabassum Siddiqui, is here to present our topic on biofilm. Biofilm perform everywhere, so it is very necessary to know about biofilm. Biofilms are communities of microorganisms in a matrix that joins them together and to living or inert substrate. A structure community of bacterial, algal, or other types of cells enclosed in self-produced polymeric matrix and adherent to an inert or living surface. Bacteria prefer a sessile community existence when possible, as this provides several advantages over a planktonic lifestyle. So, as when a green mat growth occurs in a pond which is full of water, that what we called as biofilm. So now we will study how biofilm occur. Biofilm have three stages. The bacteria then form a monolayer and irreversible attach by produce an extracellular matrix. Next, a microcolony is a form where multilayers appear during layer stages. The biofilm is a mature forming characteristic mushroom structure due to the polysaccharides. Finally, some cells start to detach and the biofilm will disperse. For example, the bacteria Staphylococcus aureus, Staphylococcus mutans, Salmonella typhi, Enterococcus facialis, Pseudomonas aeruginosa. Salmonella species are capable of adhering to materials and forming biofilms on a wide range of food contact surfaces and equipment in a food processing environment. Salmonella may be transferred to food through cross-contaminating during processing and preparation. Next is bioremediation. Biofilm-mediated remediation can harbor diverse species of both aerobic and anaerobic bacteria that often use the degradation of pollutants as an energy source. During aerobic degradation, bacteria can use oxygen as final electron acceptor to break down toxic contaminants into in-course products, mainly carbon dioxide and water. In anaerobic condition, electron acceptors such as nitrate and sulfate can play a role of oxygen to transfer contaminants into less toxic or harmless substance, and the byproduct may depend on the electron acceptor. As we have studied all the prospects of the biofilm, now we will see the future role of biofilms. First, control of bacterial biofilm that are harmful to human society. Next, utilization of beneficial bacteria with high production biofilms. Next, in-depth investigation of regulatory mechanism for the formation and dispersion of bacterial biofilms, especially researches related to beneficial biofilms. Next, elucidation of interactions mechanisms of bacterial biofilm with inanimated or living body interfaces. Next, development of new commercial products based on bacterial biofilms. Last, exploration of application SIMs for bacterial biofilm products. Thank you, ma'am.
Okay, thank you, Mr. Tabassum. The next contestant or participant is Mr. Pradeep Shukla. Okay. Next participant is Dr. Hitesh Singadia. Hello, sir. Hello, Dr. Hitesh. Sir, your voice is not audible. Sir, it is still not audible. Hello. Hello, sir. Sir, your voice is not audible, sir. Sir, can you please try to rejoin the stream? Your voice is not audible. Hello, sir. Hello, sir. Sir, your voice is not audible, sir. Sir, please try rejoining the stream. Sir, your voice is not audible yet. No, sir, your voice is not coming. Can we try like rejoining you later after one presentation? We are not able to hear, sir. I will see what is the issue and then I will let you know, sir, in a while. Okay, the next participant is Miss Akriti Thakur.
Ma'am, can I share my screen?
Just a minute, we are just waiting for your file. I will display it in a minute, okay?
Okay.
Hello. Yes, Ms. Akriti.
Yes, ma'am, just sharing my poster.
Okay, yes, you can start with them.
So, good evening to one and all present here. So, today my topic is resource recovery and pollution remediation using biochar made from municipal solid waste. So, nowadays we can see that people are focusing on decomposing their waste. So, is that good? So, let's start. Municipal solid waste output in the world exceeds 1.3 billion tons per year and is expected to rise to 2.2 billion tons per year by 2025. Most underdeveloped nations dispose of municipal solid waste by open dumping, despite certain attempts at environmentally being alternatives such as composting and vermicomposting earning worldwide attention owing to the low cost of converting trash into usable forms. In the developing nations, open dumping of municipal solid waste is a typical form of trash disposal, resulting in pollution through gaseous emissions and landfill leachate discharge. Biochar is a carbonaceous substance made from any biomass that may be utilized to turn municipal solid waste into a valuable product for resource recovery. So why we need it? Dumping is an option for us. But dumping can open dumps are one of the biggest sources of methane gas emissions, which contribute to global warming. Biochar has made a name for itself in the material science world thanks to its superior absorption qualities for cleaner water and healthier soil. So basically, incineration is mostly used for non-biodegradable trash with low moisture content or for urban garbage with low moisture content. Although incineration offers numerous advantages over landfill disposal, such as high percentage volume reduction in a little amount of space, it also has several drawbacks. The high cost of engagement and the wetness of the waste limit its use in underdeveloped countries, particularly those in the tropical zone with considerable annual rainfall. Municipal governments in underdeveloped nations are projected to spend 20 to 50% of their but a present budget on solid waste management, which comes from less than half of the city's population. Despite the fact that open dumping is common in low and middle income nations, it releases a variety of environmental toxins in the environment, like greenhouse gases, volatile organic compounds, potentially toxic elements, and persistent organic pollutants are among them. Open dumps are one of the biggest source of methane gas emissions, which contribute to global warming. So basically, here this wait a second. So here, this process will show that from biomass with several processes like thermal conversion, we'll do incineration, direct combustion, and through thermochemical conversions like gasification, pyrolysis, torrefication, we'll achieve these biochar. So what we can understand from thermal conversion. In this, we use heat or thermal energy as the leading mechanism to convert biomass energy into another chemical energy. In case of thermochemical conversion, decomposition of organic matter of the algal biomass for the production of biofuels. And in the next steps like gasification and pyrolysis, the biochar is effectively produced by the process of pyrolysis, which means that slow pyrolysis is conducted at 400 to 600 degrees Celsius to maximize the biochar yield with bio-oil, gases, and methane, ethane, hydrocarbons as byproduct. And it is really useful for environment as well, as this picture shows that biomass with the process of pyrolysis it converted into biochar, then absorption of nitrogen is there, and then it improved the soil's quality and its properties. So basically the conclusion of it is that the ever increasing volume of municipal solid trash generated on a daily basis demands recovery solution as bioresources that may be transformed into valuable products rather than being thrown in landfills, hence reducing environmental and economic difficulties. Biochar's ability to improve soil characteristics and hence plant development, resulting in increased yields, has also been demonstrated. It is a greener strategy to reuse discarded garbage and one of the sustainable strategies to recover nutrients in soil matrices. That's it for my poster. Hello.
Thank you, Ms. Akriti Thakur. The next participant is Dr. Hitesh Singhadia.
Yes, ma'am. Am I audible?
Yes, sir. Now you're
Hello?
audible. Yes, sir.
Yeah. Yeah.
Okay, you
Apologies,
may start.
ma'am. There was some technical issue, and so I
No
wasn't able
problem.
to. I could hear
No
you, but
problem.
you all were not able to hear me. So
Yes,
apologies
sir.
for that.
Okay, okay. No problem, sir. You may start now.
Yeah. Yeah. Okay. Very good evening to the dignitaries on the dais, my fellow uh, presenters and the organizers. My topic for today's presentation is occurrence of two xenoestrogens in my analysis that I have carried out. There is occurrence of monomethyl phthalate and bisphenol A from the muscle tissues of few of the commercial fishes which are sold in the local fish market in Mumbai. Next, please. Yeah, this is the abstract. So I would not actually go through the abstract and keywords, which I will actually be discussing during my presentation. So next slide, please. Yeah, basically when we talk about pollutants, be it anthropogenic or be it industrial, basically it is the human biomonitoring which is very, very requisite and is acting as a tool for evaluating the harmful effect of or exposure to various potential chemicals which can have a profound impact on not just environment, our health, organisms, foodstuff, lifestyle, and basically through various means and mechanisms, knowingly, unknowingly, they enter into our ecosystem and harm the environment, thus resulting as pollutants. However, the uptake of such noxious waste material transpires directly from the surrounding marine environment or waters across the absorptive body tissues and surfaces and from the food in conjunction with the seawater, because there are variety of organisms which are filter feeders, and directly the pollutants might enter through their respiratory surfaces, through their alimentary canals, to their mouth, etc. And finally, it reaches to the target organs, resulting into the ability of biomagnification and harm. One such thing is xenoestrogen, which is often associated with sewage outfalls and industrial sites, which are the two main reasons for these xenoestrogens, which are actually endocrine disruptors. Recent studies have also suggested that public may be exposed to one of the type of xenoestrogen named as bisphenol A by handling certain cash registers, receipts, apart from the plethora of sources through which these xenoestrogens enter into our system. Another one is the variety of phthalates, which are in form of their esters and are widely used as a plasticizer in the industry and in our daily products. Next, please. However, then what is how directly or indirectly fishes are responsible to get impacted by this? Yes, they are. And indirectly through these fishes, when we consume these proteinaceous
from these fishes basically we get into us. So fishes will get it from the environment, which is polluted from the environment into the microscopic food which they actually devour upon the invertebrates, and finally they have been used or analyzed as an indicators of various pollutants for investigation in the environment and also the health status of the populace of the environment. However, the bioavailability of various xenoestrogen compounds act as a key factor in certain tissues of aquatic biota, aquatic organisms. And researchers have raised concerns as some of the laboratory animals studied by various researchers, they have found and they have reported that these xenoestrogens, in particular by bisphenol A, is responsible to cause developmental defects in the fetuses and in the newborn individuals. However, this has found to be ubiquitously distributed and hence easy source for causing endocrine disruption, causing teratogenic impact on the survival growth of the developing individuals or the embryos. However, the aim of the study was to survey the actual presence of these xenoestrogen, to be precise, the bisphenol A and monomethyl phthalate in the muscle tissues of some of the commercially important fishes which are sold in the markets or fish markets around Mumbai. Next, please. Now we will be discussing the materials and method. Next slide, please. Yeah. Now, the study was aimed to investigate various metal component, which is not within the scope of the present paper, but this is also one of the aspect that we had focused upon. However, today's presentation, we will be focusing only with respect to xenoestrogens. So marine and estuarine fishes, which are basically sold in the fish market, including the crustacean, both the fin fishes and the shellfishes, that these are the crustaceans like prawns, crabs, and also the mollusk like green lip mussel, which is favored delicacies not only in the by the local populace, but also delicacies in the restaurant, where many of the tourists also consume them. The crustacean shellfishes includes prawns, two varieties, Peneus indicus, so called as the tiger prawn, and second is Solenocera crassicornis, which is commonly sold along the within the markets. And the second variety is the low priced compared to the first, which is normally purchased by the elite citizens of the state. Crabs include Silacerata, Neptunus pelagicus, and Charybdis cruciata. Again, here Silacerata is highly priced, whereas the other two are comparatively low priced. Third is the molluscan shellfish like green lip mussel called Parna viridis. Next, please. In continuity with the material and method, following species of the fin fish were also analyzed and an exhaustive study was carried out. Shark, that is Scoliodon soracova, stingray, Deciatus arnac, or mackerel, Rastreliger canaguta, oil sardine, Sardinella longiceps, seerfish, Scomberomorus gatatus, silver pomfret, Stromatous cinereus, Indian salmon, Eleutheronema tetradactylum, Bombay duck, which is called as Harpodon niharius, common sole, that is Cynoglossus elongatus, ribbon fish like Leptura canthus lepturus, and black pomfret variety Parastromatous niger. Next, please. Yeah. Now, basically, when we talk about the xenoestrogen, the gas chromatography mass spectroscopy method was employed as studied by Hatcher et al. 1988, and also the procedure was further compared as per the methodology available in AFA, American Public Health Authority, 2005. The wet tissue, muscle tissue was digested overnight in the mixture of solvent, that is dichloromethane and methanol, 2:1 volume by volume. It was eventually filtered using Whatman filter paper number 2. 4 ml potassium chloride solution was added to the filtrate and centrifuge at 1000 rpm for 10 minutes, wherein the organic layer was collected. It was evaporated to dryness using roto-evaporator and redissolved in methanol hexane 1:20 volume by volume mixture for estimation of xenoestrogen. And to substantiate our finding, we had made use of statistical tools basically carried out as per the ZAR 1984, that is Statistical Package Program. And inter-heavy metal correlation was also analyzed. And finally, the xenoestrogen content was found out. Pearson's correlation index was analyzed as per the Pentecost 1995, and p-values which were less than 0.05 or less than 0.01 were considered to be indicating the statistical relevance and significance of our observation. Next, please. Yeah, so this is about the results and discussion. Basically, our observation was summarized after finding out the level of these xenoestrogen compound, both, that is monomethyl phthalate and bisphenol A. Monomethyl phthalate ranged in all these organisms in the range of 12 to 51 nanogram per gram, while bisphenol A ranged between 5 to 68 nanogram per gram of the muscle tissue in finfishes, while in case of monomethyl phthalate, it was found that 18 to 26 nanogram per gram and 8 to 36 nanogram per gram in the muscle tissue of shellfishes respectively, which is seen in table 1 and 2 and figure 1 and 2 in the succeeding slide you will see. However, the highest concentration of both these xenoestrogens were detected in Sardinella longiceps and another variety of fish, which is basically the S. serrata. Bisphenol A was the only xenoestrogen detectably present in S. serrata among the shellfishes, while in the green lip mussel, that is Panna viridis, both were not detected. So this is one of the key observations, that mussels do not bioaccumulate this particular xenoestrogen. However, in case of cartilaginous fishes like S. soracova, that is Scoliodon soracova, or Deciatus arnac, both being, and certain other demersal fishes like Cynoglossus elongatus, only bisphenol A was observed to be present. However, excuse me, please. I'm sorry, my battery is low. I'll just get it connected. Just give me a minute, please. Yeah, sorry. Okay. Now, with respect to the risk or levels of risk with the xenoestrogen compounds, BPA, that is bisphenol A, levels in the environment can be based, which is mainly based on the observed significance found in the variety of fishes. One among them is the study made by Lindost in the rainbow trout. However, at certain selected locations, they found that bisphenol A is found in the fishes which were studied, showed that bisphenol A varied from 2 to 75 nanogram per gram in the liver, while in case of mussel, the concentration was lower, 1 to 11 nanogram per gram. Similarly, based on the present measured concentration in the surface water and on the literature derived toxicity data, Belfroid also in 2002 had concluded that ecotoxicological effects nor the estrogenic effect are likely to be occurring within the field situation because their concentration is low, and many a times the technology is such that we are not, even if it is present, our technology is not able to detect them because of their such a low level concentration. However, it was Yezi Kim et al. In 2020 had also made a study on bisphenol A concentration, and they found it to be higher in males or men who frequently consumed large fish such as tuna, shellfish, and other seafood compared to the smaller ones. So these were some of the notable observations which are in contributions made by certain other researchers, which actually substantiates our finding also. Next, please. Hello? Yeah. Yeah, so this particular slide, you will see the concentration of xenoestrogen as seen as shown on the table displayed on your screen. You can see the monomethyl phthalate and bisphenol A in the concentration of nanogram per gram. Similarly, we can see the graph also here. As mentioned, that these two fishes, that is Scolodon sorokoi and Decitus arnac, did not show the presence of MMP, or I can say that probably the level or the concentration was below the detectable limit of our instrument. However, in case of Harpodon nereus, bisphenol A was not detected, while in case of Cyanoglossus elongatus, again MMP was not detected, while in case of Lepturacanthus savala, it was bisphenol A which was not detected. While all the other fishes, they showed some or the other contaminant or pollutants within their muscle tissue. This is with respect to the xenoestrogen levels found in the fin fishes, the muscles of which we relish as a protein-rich food, and often it is basically having good amount or rather high amount of omega-3 fatty acids, docosahexaenoic acid and icosapentaenoic acid, which is supposedly very good to keep the health of our heart and make our body healthy. But lesser we know that along with these healthy nutrients, our body is also getting an influx of certain harmful endocrine disrupting chemicals like monomethyl phthalate or bisphenol A, so-called xenoestrogens. And unknowingly, we are basically depositing these in our system by accumulating them. However, the biomagnification may lead to serious health implications. The next slide, please. We'll see the level of our xenoestrogen in the muscle tissue of shellfishes. Very notable observation here is that Parnaviridis did not show presence of any of these xenoestrogen. Again, I would narrate the same. Probably our instrument limitation might be the reason that we couldn't detect these two xenoestrogens, or probably that this organism does not bioaccumulate, while we know the fact that mussels, or so called as the mollusks, are known for bioaccumulation of heavy metals. We can't ignore the fact that we have gathered in past in the history the Minamata disease, also called, which is because which was caused because of mercury poisoning, or itai caused because of the cadmium poisoning. We know the fact, but fortunately we can say that this particular organism or mollusk here is not showing the presence of these xenoestrogens, while in case of S. serrata, basically it is found that only the bisphenol A was detected in this particular species of the shellfish, while the others showed presence, all the others showed presence of monomethyl phthalate. This can be, so from this observation we can conclude that yes, is monomethyl phthalate is one such indiscriminate pollutant which is readily entering into the living tissues of the aquatic organisms, and through that source it may enter into our body system, thus intoxicating our system and causing a harm in our body. Okay, yes, you can see the graphical representation also simultaneously with the tabular form. Next, please. Yeah, so here comes the time for us to as a researcher to give an alarming signals to this from our study to the local populace, to the populace of the world, that yes, what are the sources and how can we prevent the pollutants from entering our system. We can, by these recommendations, basically we are trying to make the world aware that yes, it is so very harmful that even at nanogram level it is causing harm, and it is responsible for bioaccumulation and biomagnification. And once they enter into the system, they do not leave our system, and they basically would start endocrine disruption, and that would result into the teratogenic effect of this particular said chemical. So let us avoid the microwave polycarbonate plastic for food containers. Polycarbonate is basically a very strong and durable, but yeah, and that is one advantage. But over time, over the period of time, it may break down from repeated usage at high temperatures, and as a result of which it may start passing on or releasing such xenoestrogens into our food, and from that food entering into our system. Also, we should avoid plastic containers which are marked with #7. Now, #7 basically implements the level of bisphenol A, polycarbonates, and lexan. Okay, so always read on the or at the bottom of these containers whether it is marked with this particular figure. Avoid washing polycarbonate plastic containers in the washers if you are using, especially with harsh detergents that actually enhances the ability of membrane dissolution and making our cells porous. Thus, entry of such
Hello, sir.
potent chemicals becomes easy.
Hello.
Yes, ma'am. Just
Sir,
a
can you
minute. I
please
will.
just conclude? Okay, yeah. Just conclude a
Yeah.
little fast.
Yes, yes. So now our conclusion is, as from the observation, is that basically finfish and shellfishes are the integral part which are protein-rich food in our system, and so biomonitoring should be enhanced so that we can minimize the entry of such pollutants in our system, because these pollutants, when exported partially into our system or deliberate entry of these in our system may trigger our or may result into endocrine disruption, finally resulting into so-called as xeno and that is xenoestrogen effect. These are some of the references. Next, please. Yes, next, please. Thank you. Thank you so much. I'm thankful to the organizers for giving me this platform to present my research work, as well as I'm thankful to the authorities and the chairman of the session for allowing me to share my research. Thank you so much. If there is any question, the platform is open for discussion. Thank you so much. Yes, ma'am. Are there any questions? If not, then you can take the next presenter.
Thank you so much, sir, for such an insightful presentation. Okay, I would like to express my thanks to each and every participant. Now, I would like to invite our last speaker for today's session, that is Professor Cristiano Jose de Andrade, Professor of Department of Chemical Engineering and Food Engineering at Federal University of Santa Catarina, Florianopolis, Brazil, and Dr. Sachin Munde, Associate Dean, School of Science, Sandip University, Nashik, to chair the session. I now request Dr. Munde to introduce our expert. Over to you, sir.
Thank you. Okay, am I audible? Thank you. So I would like to welcome Dr. Cristiano Jose de Andrade for the session. Professor Cristiano is a professor in Department of Chemical Engineering and Food Engineering, Federal University of Santa, Brazil. So particularly, Dr. Andrade has plenty of experience on biotechnological processes, in particular fermentation, bacterial metabolism, byproducts with high surfactant activity, purification processes, that is ultrafiltration, algae cultivation, and green-based extraction methods. Along with this, he's also having expertise in identification of biomolecules by mass spectrometry. Dr. Andrade works as a professor in the Department of Chemical and Food Engineering, EQA, Federal University, as I already told you, University of Santa Catarina, Brazil, and also in the graduate program in chemical engineering at UFSC. So, apart from this, Doctor has published 38, more than 38 scientific articles, 13 book chapters, and 2 patent he deposited. So, with his vast experience in research, I would like to welcome Dr. Andrade for the today's session. Doctor, welcome. And now the session is yours.
Okay, are you listening to me?
Yeah, yeah.
Okay. Thank you for this opportunity to share, to present a bit of my work, and I really thank you for that. Let me share my screen. Are you seeing that?
Yes, sir.
Okay, thank you. So, thank you for this opportunity. My name is Cristiano. I'm gonna give a talk entitled Hydrophobic Inducers to Enhance it Surfactant Production using cassava water as a low pulse culture medium, a prospection on new homologous. And I really thank you for this opportunity to give a talk to you. So, who do you say I am? I'm food engineering. I have received my master degree in food science in 2011. And after that, I started to work as a PhD student in the University of Campinas, in which I did the split PhD in England, University of Reading, under Dr. Paula Jaurese's supervision. After that, I started to work as a postdoctoral research at the Chemical Engineering Department, University of São Paulo. And in 2018 to the present, I have been working as a professor in the Chemical and Food Engineering Department. It's worth noting that from 2009 to present, I have been working as a professor at the postgraduate program in chemical engineering. So basically, I have been give this talk in several conferences and congress and so on. It's quite nice to share ideas. And again, I thank you for this opportunity. So basically, the talk, first, I'm gonna try to relate the cassava and the concept of green chemistry really quick as a brief introduction. After that, I'm gonna talk about biosurfactant production using cassava wastewater, the oligosaccharide production, the current works and conclusion perspectives. So
Basically, the talk is related to cassava flour industry. This is cassava root, as you can see. Is personally speaking, is quite tasty food. And Nigeria, Republic of the Congo, Thailand, Ghana, and Brazil, they are the main producers of cassava. They together represent more than half of the global production. So basically, the cassava flour industry generates a plenty of residues. I mean, 1 kilogram of fresh cassava root process generated more than half kilograms of solid residues and more than 6 liters of wastewater. So it's a lot. You have to take care of these residues, otherwise they can impact the environment. Here's a kind of process of cassava flour industry. So first, the roots are washed. So degenerated, of course, a first wastewater residue. After that, the roots are cut and peeled. And of course, the cassava peel is the second huge residue. After that, you have to grind and to dry. And when you dry the cassava roots, you generated cassava wastewater, which is a quite rich residue. And after a thermal processing, you have a cassava flour. So basically, we have three huge residues when you think about cassava flour industry. And I keep wondering myself why India isn't in the major cassava producers in the world. So this is the process. We have submitted a project in order to use cassava peel and cassava wastewater in the biotechnological process. We submitted this project in 2019, and our research group won about $100,000 to carry out this project. And that this project is undertaking right now. So firstly, what is the concept of green chemistry? According to EPA, green chemistry is the design of chemical products and process that reduce or eliminated the use or generation of hazard substances. Green chemistry applies across the life cycle of a chemical product, including its design, manufacture, use, and ultimate disposal. Green chemistry is also known as a sustainable chemistry. So, in other words, if your project or your work try to minimize the impact of any step of the process related to environmental, you are doing a green chemistry. You are applying a green chemistry concept. So first, we tried to relate the term green chemistry to cassava. And we did that using the Scopus database, which is quite nice because it's easy to identify scientific trends on that. So as you can see, the green chemistry is increasing sharply, and cassava is also increasing sharply, as you can see. However, when we subdivided the reports on cassava, the most part of is related to agriculture, meaning to increasing the crops, the yields, and so on. Just about 10% is related with biochemistry. And part of these biochemistry papers or data are related to agriculture. You mean nutrients, fertilizer, and so on. There's a little information on biotechnological process on the development
of biotechnological process related specifically to cassava. So basically, they propose, or the project is trying to change the traditional industry to a bio industry or biorefinery. So basically, cassava peel can be a source of oligosaccharide, and cassava wastewater can be used as a low-cost culture medium for biosurfactant production. In this case, there's a lot of possibilities, as I'm gonna show to you. So, starting to cassava wastewater, this is a picture of cassava wastewater. As you can see, it's quite colored because it's really rich in nutrients as a starch, different sugars, minerals, and so on. Personally speaking, I have been doing this culture medium to run a fermentation with yeast, fungi, different kind of bacteria, and it's feasible for all of them. However, before the fermentation process by itself, we have to run some pre-treatments on cassava wastewater. I mean, we have to boil that, and after that we have to centrifuge that. When you centrifuge that, we precipitate the starch because there's a lot of starch. It is a really high content starch in cassava water, and in fact, there's a PhD student studying this starch. She has been doing some experiments with kind of starches, the resistant, and so on. So on the sobrenadant, after the centrifugation, we can use that for run different kind of fermentation. And after the fermentation, the most promising strategy to purify our interesting product is the ultrafiltration. After the purification, we can apply that in oil recovery, bioremediation, pharmaceutical activity, and so on. But personally speaking, I think the agriculture is the most promising alternative for that. And what kind of biosurfactant we have been producing? We have been producing surfactant. Surfactant is a lipopeptide, as you can see. So basically, we have a fat acid moiety or portion, which is related, linked, bounded to 7 amino acids, as you can see here. 1, 2, 3, 4, 5, 6, and 7. So I would like to point out that most of these amino acids, they are in L configuration, which is the most common found in nature. However, as you can see, there's D configuration also. And we think that the deconfiguration leads to the biological properties of this kind of molecule. And also, when you think about maybe I can synthesize that in the laboratory. I mean, we can bound it one amino acid to another, and so on. And after that, link it a fatty acids. But when you're thinking about deconfiguration, it is quite impossible to do that. So looks like a master plan. We have a low culture medium, low cost culture medium, which is feasible for plenty of microorganisms. I mean, yeast, bacteria, and so on. But in 2016, we have published a paper which indicates that, okay, on the one hand, it's feasible to run the fermentation process and so on. However, on the other hand,
it's quite hard to purify that after the fermentation process. Because when you think about ultrafiltration process of biosurfactants, the main point is to separate it, to purify the biosurfactants from proteins. In this case, there's too much protein in cassava wastewater. So this is a quite drawback in which we have been trying to overcome recently. There are some recent publications. Our research group has published prospectum on membrane-based strategy for downstream processing of surfactant in the Chemical Engineering Journal. To our department is a quite nice journal, and also biosurfactant inducers for enhanced production of surfactant and amlolipídio overview. So this is quite nice. I do recommend you if you have some time to take a look on it. But we have also publication on the productions of biosurfactants also. In addition, we have two book chapters. One is specific on the application of biosurfactants in agriculture, so it's quite nice if you can have a look also. And that one is related to the possibility of the use of cassava in biotechnological process. In this chapter, we describe the production of vitamins, pigments, amino acids, proteins, lipids, and so on. So there's a plenty of opportunities to use cassava water as a low cost culture medium. Of course, in this case, you minimize the impact of this kind of wastewater into the environment. So basically, we have run some preliminary experiments with specific inducers and at different concentrations. We have observed that they change a lot the microbial growth, as you can see here. The pH didn't change so much, and the indirect measurement of the biosurfactant production by surface tension variation also indicates they change a lot. That means this guy can interfere in the fermentation process by itself. Sorry about that. We have doing research also in the hydrophilic inducers. That means the first group was hydrophobic inducers, but there's also hydrophilic inducers, and they also change the microbial growth and so on. But this picture, that is the one that I really wanted to show to you. At the left here, we have the chromatogram of the standard, which was acquired by Sigma Drich. So there's different peaks on the chromatograms. That means we have different homologous of surfactant, which are the biosurfactants that we have been producing. And we have observed that the inducers have increased the surfactant production. But more than that, we have producing different homologous from Sigma Aldrich. So they are different, they are quite new. We hope further to identify the chemical structure, I mean the sequence of amino acids and the length of fatty acid, and more than that, we need to investigate it, the biological properties of these new biosurfactants. So actually, our research group is quite enthusiastic on this kind of data, which isn't published right now. And after that, the other part of our research group has been working on the purification process, more specifically in ultrafiltration process. So a brief overview is after the production of surfactant or any kind of biosurfactant, you have to separate the cells, and you can run that by a microfiltration process step or a simple centrifugation. After that, we can run a first step ultrafiltration. That means since the biosurfactants are at high concentration, they structure themselves in macro structures like this, like micelles, right? When you run the first step ultrafiltration, part of this structure are retained, and salts, small proteins, amino acids, peptides, and so on permeated. So this is the first step, ultrafiltration. After that, we can add into this solution ethanol, methanol, or any organic solvent, which is act as a disruptum, this structure. After that, we run the second step of ultrafiltration, which of course, the monomers, the surfactant, the biosurfactant can permeate it and proteins are retained. I would like it's worth to noting the size of membranes. So basically it's a quite nice strategy to purify these kind of molecules. Personally speaking, I think it's beautiful, the whole strategy. So basically, the research group has been producing ceramic membranes, which, when compared to polymeric membranes, they are wider pH range, more resistant to organic solvents, and so on. So our research group has been producing this kind of membrane and then apply to the ultrafiltration process for biosurfactant production. Our yield of purification reaches 98% of retention in the first step. I mean, we have been applying that membrane in this step, and we can retain 98% of these molecules. So it's quite impressive. It's similar to the polymeric membranes. So it was the first step, the first approach, but we also have cassava peel. Cassava peel can be a source of oligosaccharides. In this case, we have been looking just for hemicellulose part. Cassava peel has lignina, has lignocellulose also, but in this case, we are particularly interested in the hemicellulose. So after enzymatic hydrolysis, we can produce oligosaccharides with our prebiotics. That means selective stimulation of the intestinal microbiota. That means they can affect or assist or help diabetes, obesity, hypertension, and so on. So this is a picture of the industrial that provided us the cassava peel. And our research indicated a yield of production around 400 milligrams de oligosaccharides per gram of xylose. It is quite low, but we hope to increase this number, the yield, really soon. I would like to thank my research group, the Professor Deborah, the students, the PhD, the Professor Alain, master student, PhD student, master student, and uh, they do the really hard work, and I really thank you them for that. So our perspective is try to create to develop some process in order to make it greener. I'm not saying green, but at least greener. So, would you like to apply the concept of green chemistry to food industry? I really thank you, the organization, for this opportunity. In particular, Dr. Kumar, for the kind of invitation. This is my email, both, and there's a personal page to look it up and keep in touch. I'm really happy to take some questions if you want.
Yes. Yeah, it is, I think, done. Thank you, doctor. Yeah. Thank you for sharing your knowledge and your research uh, expertise on this area. Thank you very much for joining our session and experience sharing your experience with us. Thank you very much. From the School of Science, Sandip University, I would like to express my sincere gratitude to you that you shared your knowledge, your research with us. Thank you.
Thank you. Thank you. Bye bye.
Thank you so much, sir, for such an insightful presentation. Hello, sir.
हेलो हेलो लॉग आउट कर दिया ना
I would like, I would now like to express my thanks to each one of you. I would like to express my special thanks to all the speakers, that is Dr. Pankaj Chaudhary, Dr. Sunil Kumar, Dr. Kaushik, Dr. Samuel, Dr. Banerjee, Dr. VP Sharma, and Dr. Dinesh Yadav and Dr. Cristiano for your stimulating presentations. Also, I would like to thank all the participants for their insightful presentations and the audience for being here with us today. We now declare the end of today's session. Thank you. We will see you in tomorrow's session that will start from 9:45 a.m. Thank you, everyone.